Hello everyone, welcome to AS Engineering Academy and AS Online. This is Ramesh Pabba, faculty at AS Engineering Academy. Here I am with a special information regarding Pre-GATE 2025 Electrical Engineering paper. We are conducting Pre-GATE 2025. The question paper is in a jumbled way, that is in the form of main GATE exam. All subject questions are in the jumbled way. In the same way we have given the question paper, but we are giving the video solutions for all questions, and all these solutions are categorized subject wise, which offers clear way of understanding each and every question. Thereby every student can complete one subject at a time, so it will be saving your time. And in addition to this, we are having one more special information. Based on many number of students' request, we are hosting, that is our AS management is hosting one free mock test, right? Online exam. Guys, this is a free mock test. That exam we are conducting on 26th January 2025. We are conducting this exam in two sessions. One is in forenoon session. In this forenoon session, civil paper, mechanical paper, instrumentation paper and DA papers will be there. And in the afternoon session, right, electronics paper, electrical paper, production paper and CSIT paper will be there. Sir, for registering this exam, for applying this exam, 24th January is the last date, and we are going to announce the results of this exam on 27th January around 6 p.m. And the highlights of this exam is get real-time experience of GATE 2025 test pattern. So therefore, you will be getting the advantage of attending this exam. Virtual calculator will be enabled. This is also an advantage. Post-exam learning analytics and all India rank will be provided, and those ranks or those details will be, results will be announced on 27th January 2025 around 6 p.m. So my suggestion to the students is to register for this exam, and you can scan this code, right, to register for this exam, and register exam, prepare well, all the best. Thank you.
We'll see the question which were asked in pre-GATE examinations from the subject networks. I have a question like this. The Thevenin's voltage and Thevenin's resistance across A, B terminals of the circuit shown in the figure. So there is a circuit he has given. The circuit consists of dependent source, of course current controlled voltage source, and other resistors connected in series and parallel combination, and is asking the resistance across this A and B terminals. You know, as a network consists of only dependent source and resistors, there is no independent source. As there is no independent source, you don't get, you know, the Norton's current or otherwise the Thevenin's voltage. They are absolutely going to be zero, because it is not an energized network. It is unenergized network. It is a dead network. Even you touch these terminals also, you will not get any shock, because internally this network doesn't consist any active element. As there is no active element, you don't get any shock. So I can say that the Thevenin's voltage is absolutely going to be 0. So 2 cannot be the answer. 0 could be the probable answer. 0 could be the probable answer. Okay, 0 could be the probable answer. So either B or D could be the correct answer. Now let us check for Thevenin's resistance. How do you calculate Thevenin's resistance? No active elements, so no need to short circuit or open circuit some sources. You just connect a known voltage across this AB terminals. It's your wish. You want to connect a voltage source or current source, it's your wish. Okay. So the known voltage may be V. Some people assume V. They'll go ahead with the V and I equation. They'll end up with a V by I and they'll solve RTH. So if this voltage source is going to drive a current, some current I. Okay, already capital I is there, so that's why I'm writing it as I. So let me assume this voltage source value, some value, because it makes very easy. Because if you know this current value, you can find out this voltage source value, dependent source value, and that will make the calculations very easy. Okay, right. So how do you want to make this voltage, how much you want to make this voltage source value? Let us make it as 12, no? If it is make it as 12, 12 divided by 12, you will get the current as 1 ampere. Gone, finished. Now if I is 1 ampere, 8 into 1, it will be 8. It will be 8. Okay, dependent voltage source, so I am just writing it as 8. Okay. Now the voltage across till this parameter, till this nodes, it will be 12 volts only. Now you can apply nodal analysis and you can find out the currents value. At the end, you should get the resistance. The resistance must be written in terms of V by I. What is V? 12. 12 by I. So either you do this way or you do source transformation also. People can also go for source transformation. I have 8I and I have 4 ohms. It is looking like a practical voltage source, dependent source. So 8I divided by 4, you will get 2I. 2I in parallel with 4 ohms. The network looks like this. The network look like this. Okay, 2I in parallel with 4 ohms. We know you can, it's your wish, you can connect to 12 volts non-voltage source and it is going to drive a current I. Now 12 by 12, so you will get it as 1 ampere. 12 by 6, you will get it as 2 amperes. 12 by 4, you will get it as 3 amperes. What about this value? 2 into 1, you will get it as 2 amperes. So 2 ampere is entering, I is entering. How much current is leaving? 3, 2, 5. So 2 plus 5, sorry, 2 plus I is equals to 3 plus 2 plus 1. It will be 6. 2 plus I is equal to 6, I is equals to 4 amperes. So I have got I value as 4 amperes. What does it mean? This entire network is drawing 4 amperes current when you connect a voltage source of 12 volts. So which means the resistance offered by this network across AB terminals, RAB or otherwise RTH, you can call it as 12 by 4, you will get it as 3 ohms. So the Thevenin's resistance is going to be 3 ohms. So obviously I can say option D is going to be the correct answer. You can eliminate 2 options out of 4 options if you know the concept of only the network has only dependent sources along with the resistance, then it doesn't consist any Thevenin's voltage and Norton's current or short circuit current. Okay, be careful. It is equivalent to a dead resistor, unenergized network. Okay, I hope it is clear. Either you go ahead with the nodal analysis or you can go ahead with the basic source transformation and you do that, you'll get it. KCL, you'll get it. Let us see one more question. For the network shown in the figure, what is the expression for I of t? Assume that initial current in the inductor is 0. There is no initial energy in the inductor. I have a impulse signal, of course delayed by some 3 seconds, 2 del of t minus 3, and I have a RL series network and is asking a current. As it is definitely a RL series circuit, whenever you give a supply, definitely it looks like the inductor will not allow the current immediately, right? The inductor will not allow the current immediately. Okay, so definitely it looks like this. So what you need to do, you need to convert this network into S domain or frequency domain. R will be R only, the inductor will be like SL ohms, and this will be how much it will be? 2 into e power minus 3s, and this will be I of s. So your I of s will be how much now? I of s is equals to V of s divided by Z of s. So you substitute those values, you will get it, and after that you will get the apply inverse Laplace transform, you will get it. So how much it will be? 2 into e power minus 3s divided by Z of s, how much? R plus SL, that will be 2 plus s into 1. L is 1 Henry, na? Okay. So this is my I of s. You apply inverse Laplace transform. If you apply inverse Laplace transform, it will be s plus 2, na? So numerator it is 2. 2 into e power minus 2t. S plus 2, na? So exponential alpha will be minus 2. T. What is t? The t is not started at 0 point, it is delayed by 3 seconds. So t minus 3, because the excitation is not starting from 0. You can take up like if it is del of t, you would have write it as 2. Okay, so it is t minus 3. So be careful. e power minus 2 into t minus 3. So this is how actually you have to get it, and this u of t minus 3. Be careful. Delay, the response is delayed by 3 seconds. So I of t is equals to 2 into e power minus 2 times t minus 3. Yeah, this is matching. Option B is matching. Option B is matching. Most of the people will go ahead with this one. Be careful. Be careful. Okay. So be careful. Okay. Right. We'll have a look at this question. What values of RL and RC will cause the circuit shown in the figure below to be resonant at all frequencies? I have a practical inductor and a practical capacitor connected in parallel. Now, for what values of resistance RL and RC, these LNC circuits comes under resonance? I think for parallel this kind of network, the resonant frequency value is taken as 1 by root LC into root of RL square minus 1 minus L by C divided by RC square minus L by C. Okay. So when the resistors RL and RC values are going to be 0, simply omega naught is equal to 1 by root LC. But he is asking for what values the circuit comes under resonance. There is a direct case. RL value, RC value must be equal, and they must be equals to root of L by C. If it is so, the imaginary term will become 0. The imaginary term will become 0 and the circuit comes under resonance. Resonance is nothing but imaginary term. The omega term should be, j omega term should be 0. Okay. I have a L value, how much? 2 milli. I have a C value, how much? 80 micro. Okay. So let me solve this one. 2, you'll get it as 1 by 40. 10 to the power of minus 3, if it 10 to the power of minus 6, if it goes up 10 to the power of 6. So you'll remain with 10 to the power of 3. So 10 to the power of 3 is 1000. So root of 1000 divided by 40, it comes out as 25. Root of 25 will be 5. So RL value, RC value must be equals to 5 ohms. Okay. So if RL value and RC value is equals to 5, then I can say that this circuit resonate at all frequencies. The circuit will resonate at all frequencies. Okay. I have a question like this. The network of figure attains steady state with the switch closed. With the switch closed. If the switch is closed, the network attains a steady state. And is asking that, he's telling that at t equals to 0, when the switch is opened, at t equals to 0, the switch is opened. Which of the following statements are correct? He has given some statements. The voltage across the capacitor Vc at t equal to 0 minus is 2 volts. The inductor current is 1 ampere at t equal to 0 plus. The voltage across the switch Vk at t equal to 0 plus is 0 volts, and dVk by dt at t equal to 0 plus is 4 volts per second. The rate of change of voltage across the switch he has mentioned. Okay. So if you want to observe those values, let us take up the initial situation and then next after switching action. Okay. He initially is saying that the network attains a steady state with the switch closed position. So switch is opening at what position? At t equal to 0. That means what? From t equals to minus infinity to 0 minus, the switch is in closed position. From minus infinity to 0 minus, the switch is in closed position. Okay. If the switch is in closed position for a long time, is that source is connected? Yes, the source is connected. This 2 volt source is going to drive the current through inductor, and of course it is also going to drive the current through capacitor. Inductor and capacitor are going to charge and they'll attain the steady state. If they attain the steady state, by the time by the time you are going to open the switch at t equal to 0, just before the opening the switch, that is t equal to 0 minus, this situation is called as, or this instant is called as steady state instant. Because a long time the source is connected. If the source is connected for a long time, the inductor and capacitors will charge and it will store the energies. Definitely they will reach the steady state. In the steady state, inductor behaves like a short circuit and capacitor behaves like a open circuit. You replace the inductor and capacitors with short circuit and open circuit. Inductor with short circuit, capacitor with open circuit, and find out the currents and voltages across them. Okay, so at t equals to 0 minus, this is the network. Switch is closed, capacitor is open circuited, inductor is short circuited. Now you see, this 2 volt source is going to drive the current through the switch and also through the inductor through the 1 ohm resistor. Okay, is there any current through the capacitor? No, because capacitor is open circuited. Right, in the steady state capacitor is open circuited. Now IL of 0 minus is equals to voltage divided by resistance, you will get it as 2 amperes. So IL of 0 minus is equals to IL of 0 plus. Inductor will not allow the current suddenly. Inductor will not allow the current immediately. Right, inductor will not allow the sudden changes in current. So IL of 0 minus, IL of 0 plus is 2 amperes. What he has mentioned, the inductor current is 1 ampere at t equal to 0 plus. Is it true? No, no. This is absolutely false. Any other voltage across the capacitor? Voltage across the capacitor, Vc of 0 minus is 2 volts, he is saying. Let us see. You see here, the switch is closed, which means what? Short circuit or not? Switch is closed. What is the value of resistance of that switch? The resistance of the switch is going to be 0, no? Even though the current is 2 amperes, 2 amperes into 0 ohms resistance, it will be 0 volts only. So Vc of 0 minus, Vc of 0 minus is going to be how much you are going to get? It's going to be how much? 0. So Vc of 0 minus is 0. Vc of 0 plus is also going to be 0 or not? Why? Because capacitor will not allow the sudden changes in voltages. So Vc of 0 minus is 0, but he has mentioned that 2 volts. No, absolutely wrong. Option A and option B are absolutely wrong. Now let us have a look at C and D. The voltage across the switch Vk at t equal to 0 plus is 0 volts. At t equal to 0 plus is asking. That means what? Just after opening the switch. So from 0 minus to 0 plus, what is the time? It is 0 only. So we call this state as transient state. Immediately after the switching action, immediately after the switching action is nothing but transient state. In the transient state, inductor behaves like open circuit, capacitor behaves like short circuit, because it doesn't want to allow the sudden changes in currents and voltages. Inductor wants to allow the previous value of current only. Capacitor wants to maintain the previous value of voltage only. That is the reason why it wants to it will become open circuit and capacitor will become short circuit. So at t equal to 0 plus instant, the network look like this. The network is in transient state. Here the network is in steady state. Whether the network is in steady state or transient state, the network is of resistive nature. Remember that point. You see. Now here switch is opened at t equal to 0 plus. What is the behavior of capacitor? Short circuit. What is the behavior of inductor? Open circuit. But replace their initial values, previous values. So the capacitor Vc of 0 minus and Vc of 0 plus, how much? 0 volts, previous value. IL of 0 minus and IL of 0 minus. IL of 0 minus, previous value, how much? 2 amperes. Okay, right. What is asking? The C option, the voltage across the switch Vk at t equal to 0 plus is 0 volts. Is it so? Yes, it's a short circuit. Vc of 0 plus is how much? That is equals to Vc of 0 minus. You will get it as 0 volts. Yes or no? So voltage across the switch at 0 plus instant is going to be 0 volts. So do you have any voltage across a capacitor? No. So I can say that option C is a correct statement. True. Option D, dVk by dt at t equal to 0 plus instant is 4 volts per second. How do you calculate the change in voltage across the switch? If you want to calculate the change in voltage across the switch, you need to calculate the change in current through the capacitor. The current through the capacitor IC can be taken as C into dVc by dt. I want a t equal to 0 plus instant. So IC of 0 plus divided by C is equals to dVk by dt or dV of 0 plus by dt. Is there any current which is flowing through the capacitor at t equal to 0 plus? Yes. How much? Inductor previous current. How much? 2 amperes. It is flowing through 1 ohm resistor, 2 volts voltage source and the diversion. It will divert like this. So the current flowing through the capacitor at t equal to 0 plus instant is how much? 2 amperes. And what is the capacitor value? I think 0.5 farads, 0.5 farads. Now this is my voltage across the switch just after opening it. The change in voltage across the switch just after opening it. 2 by 0.5, you will get it as 2 into 2, probably 4. So 4 volts per second. So voltage across the switch is changing as 4 volts in a second. Okay. So I can say that option D is also correct statement. Option D is also correct statement. Okay. So on the whole, option C and option D are correct statements. This is an MSQ. Look at this question. For the circuit shown in figure, the value of quality factor Q is. The circuit is given with some resistor, inductor, capacitor and with a dependent source, voltage controlled current source. He is asking quality factor. So let us, if you want to, if you want to find out the quality factor, you should operate the network under resonance condition. Should operate the network under resonance condition, because quality factor omega L by, the formulas are there, but anyhow, if you operate the network under resonance condition, okay, the energy in the inductor will be half Li square na. The energy in the capacitor will be half CV square na. Okay. Quality factor is nothing but what? Quality factor of the inductor generally. Dissipation factor of the capacitor we will take up, reciprocal. If you want to test the quality factor of the inductor, you should allow maximum current through the inductor. When will you get maximum current? If the circuit under resonance, series resonance condition, the current will be maximum. Under parallel resonance condition, voltage will be maximum. So if you want to test the capacitor, parallel resonance is preferred. If you want to test the inductor, series resonance is preferred. So anyhow, he has given RLC. So you take up this dependent source network and convert into voltage source manner. Okay, voltage source manner. Okay, so how do you convert 0.3 VR current into ohmic value? Ohmic value is what? 1 by j omega C. 1 by j omega into 30 into nanofarad, na? So 10 to the power of 9. So 0.3 VR into j omega 1 by j omega 30 into 10 to the power of 9. So this is my voltage source magnitude. Be careful, the current source direction is downward, so plus minus like this you will get. And anyhow, the capacitive reactance value will be in series with the existing other two parameters. Now here also you can write j omega L. So j omega L value is 1 millihenry. Okay. So these are my ohmic values. Okay. So if you convert like this, it looks like a series RLC circuit. It looks like a series RLC circuit. So if it looks like a series RLC circuit, we should allow the network, you should bring the network into resonance mode, allow a large value of current so that you can store maximum value of energy in the inductor. That is where you'll get to know how much energy can be stored in the inductor, and based on that you can decide the quality factor. If the inductor stores less amount of energy, I can say that that is not a quality inductor. Yes or no? If it is dissipating more and more heat, if it is storing less amount of energy in the magnetic field, that's a worst inductor, no? So allow maximum value of current so that you will come to know how much energy it is storing. If it is storing maximum energy, it's a good inductor. If it is storing less energy, it's a worst inductor. So let us convert this network into, see just in a single loop manner and solve it. So this is how the network looks like. So VR current into the reactance. I have written the all these values. Now after getting this one, you see the network has dependent source and the rest, ohmic values. So anyhow, you should connect a voltage source, and this voltage source divided by current, you will get the impedance. Because he is asking what? He is asking quality factor. So as it is series network, I am going with the series RLC network, the quality factor will be omega naught L by R. Omega naught L by R. So if you can calculate the resonant frequency, you can calculate the quality factor now. Okay. So to calculate the resonant frequency, under resonance condition, what will happen? The ZTH real term plus imaginary term. This imaginary term will be 0. So take up that imaginary term and make equal to 0, you will get the omega value. Once you get the omega value, substitute here, you will get the quality factor. Okay. So let us do that one. So I have a known voltage source which is driving a current I, and that current I is flowing through this network. So if I flows here, what is VR here? So VR voltage drop across the 10 ohms will be 10 into I. According to the current direction, the polarities are given. In the network itself, the polarities are given. So I assume the current direction to match that polarities. Okay. So wherever VR is there, I can replace with 10I. So here also I have VR. Now simply you can write a KVL and write in terms of KVL, so you will get it now. So let me go ahead with this. Okay, let me go ahead with this one. So if I solve this one, plus V minus I into j omega into 10 to the power of minus 3 minus VR is going to be, VR is how much? VR is how much? 10I. So minus 10I into 10, it will be 100I minus 10 to the power of 9 divided by j omega into 30. And what I left with this one. Be careful, don't change the polarities of this voltage source. Okay, don't change the polarities of this voltage source, already polarities are there. So leaving polarities plus, so plus 0.3 VR plus 0.3 VR plus 0.3 VR into 10 to the power of 9, into 10 to the power of 9 divided by j omega 30. Okay, so this is the voltage KVL equation I am going to get. So you can take up I terms separately, So if you take up I terms, anyhow, and this VR also has, moreover, this VR also has what? 10I, na? So you can replace 10I. So all these terms has I terms. So you can take up common now. I, if you take up common, then it comes out as j omega into 10 to the power of minus 3 plus 100I, or plus simply 100, and this plus 10 to the power of 9. If this j omega, if this j goes up, it will be minus j, or let me write this as j omega 30 plus 0.3 into 10, it will be 3I. So I have taken common, so 3 into 10 to the power of 9 divided by j omega 30. So this is how it is looking like. Let me even write much more clear. All I terms I have taken common. So let us take up the real terms and imaginary terms separately. So V by I is equals to, real term I have only 100, and let me make out imaginary terms as like this. So j omega into 10 to the power of minus 3. If this j goes up, it will be minus j. So minus j into 10 to the power of 9 divided by omega 30 minus j into 10 to the power of 9 divided by 3/10. So I get this as omega into 10. So this V by I looks like this. This V by I is nothing but ZTH, na? So I have a real term and I have an imaginary term. So make the imaginary term equal to 0. So let me make the imaginary term equals to 0. So if I make imaginary term equals to 0, I'll get like this. So j into 10 to the power of 9 divided by omega into 30 plus j into 10 to the power of 9 divided by omega into 10. Yeah. So if you try to solve this one, 10 to the power of 9 j, you can take up common 2 divided by omega, like that. Okay. Anyhow, so let me end up this. Don't, let us not get into the entire calculations. You can solve them. I'll get some omega naught. You cross multiply, you'll get some omega naught radians per second. Okay, you'll get some omega naught radians per second. So after getting that omega naught, you substitute here omega naught into the inductive reactance. How much it is? 1 milli. Sorry, inductance. What is the resistance value? The resistance value 100. Is there any change in resistance? Oh, probably I have got it as 110 into, I think I made a, I changed this one, be careful. Actually, I should take up only the voltage drop across this one. So voltage drop can be taken as simply 10 into I only. It should be 10 into I, not 100 I, it should be 10 into I. Okay, it should be 10 into I. So be careful, any calculation mistakes are there, be careful. So it should be 10 into I only. So the real term you will get this as 10 only. Okay. So omega naught, you solve it, probably you'll get that one and you'll get it around some kiloradians, 365 some kiloradians you'll get anyhow. Okay. Remember, I wanted to tell you one point here. A capacitive reactance in parallel with the dependent source. So there is a change in capacitive reactance value. Generally, when a resistance is connected in parallel or when the resistance is placed in accordance or in conjunction with the dependent source, that element nature is going to be changes, that element value is going to be changes. So as a capacitor is connected in parallel with the dependent source, the capacitive reactance will change. If a resistor is placed, resistor value will change. If inductor is placed, inductive reactance value will be changed. That's the reason why you see here the real term, the resistance value is not changed. The resistance value is not changed. So be careful. Okay. So resistance value still is going to be 10 only. Okay. So you end up this, try to solve this omega naught and substitute here directly, you will get the answer Q. Okay. We'll see one more question here. The question is like this. For the network shown in the figure, the value of RL for maximum power transfer. What is the value of load resistance for maximum power transfer? And the maximum power transferred are respectively. What is the value of maximum power transfer to the load resistance? Is asking RL value, is asking PL max value also. Both. Is asking maximum power also. Okay. So how do you get this RL value? Generally we do what we do, you just disconnect this secondary port so that you can calculate VTH and RTH, and that RL must be equals to RTH. Yes or no? Disconnect this, make I2 equal to 0, disconnect this means what? Make I2 equal to 0, calculate VTH, calculate RTH. Now your RL must be equals to RTH for maximum power transfer. Whenever you disconnect the second port, I2 equal to 0, you substitute I2 equal to 0 in the two-port network equation. I have got ABCD parameters. ABCD parameter equations, you see, be careful about the current directions. Current is into the network. So I can take up sending end voltage is equals to receiving end voltage plus the drop. So A V2 plus B I2. V1 is equals to A V2 plus B I2. I1 is equals to sending end current is equals to C V2 plus D I2. Anyhow, I am making I2 equal to 0. So left out terms you can substitute and write down. And while writing V1, be careful, V1 is not directly, don't substitute 100. V1 is the voltage across this input port after some drop in the 20 ohms resistance. How much drop it is? 20 times I1. 100 minus 20 times I1. So V1 is what now? V1 is 100 minus 20 times I1. Okay, so replace that and solve for VTH. So I'm replacing V1, 100 minus 20 times I1 is equals to 4V2. I2 I am substituting 0. Okay, so the second equation, how it looks like, I1 is equal to 0.4 times V2. I1 is equals to 0.4 times V2. Now you substitute this I1 here. So 100 minus 20 times 0.4 times V2 is equals to 4 times V2. What is V2? Secondary side port voltage, na? VTH, na? Directly. So 20 into 0.4, it will be 8. 8 V2, send on to the right side, it will be 8 plus 4, 12. So V2 is equals to 100 by 12, which is nothing but VTH. 100 by 12, it will come out as even 12 5s are 60, yeah? So 12 8s, maybe 12 7s, like that. Okay, not even 12. Okay, let us check that one also. 100 by 12. I am getting it as around 8.33. He is not asking Thevenin's voltage, he is asking what? Thevenin's resistance. So if you want to calculate Thevenin's resistance, you need to replace the independent voltage sources by their internal resistances and independent current sources by their internal resistances. Okay, so I have an independent voltage source replaced with internal resistance, that is 20 ohms. So you can replace it with short circuit. Short circuit means what? How do you get? If you short this one, what is V1 now? V1 is going to be just minus 20 times I1 only. Okay. Now when you solve for RTH, what is this V1? Minus 20 times I1 is equals to, this is AV2. This V2 is nothing but what? Open circuit voltage on the side. So here, to calculate the Thevenin's resistance, we connect a known voltage source. You connect a known voltage source and drive some current I. Okay. So this is V2 and I2 you can take up. Whatever the current which is driven by the voltage source. You connect a voltage source that is going to drive some current. I am assuming that as I am assuming this voltage as V. So that's the reason why I am replacing V2 as V, I2 as I. So minus 20 times I1 is equals to 4V plus 20 times I. Okay. Now what about this? What about this equation? I1 is I1 you can substitute here now. Minus 20 times 0.4 times V plus 3 times I is equals to 4V plus 20 times I. 20 into 0.4, 8V minus 8V, 60 minus 60I is equals to 4V plus 20I. Voltage will be around minus 12 volts, minus 12V, and this will be around 80I. So V by I will be 80 by 12. So 12 5 is 60, no? So more than 5. So 80 by 12 coming out as around 6.67. So this is my RTH. This is my RTH, 6.67. So there are two options which are matching. Option B and option C are matching. So we have solved only RTH. Now you need to solve with the PL max also. So what is PL max? How do you solve PL max? You replace the network with Thevenin's voltage, Thevenin's resistance, and connect the load resistance and vary till RTH. So for PL max, what is the formula? Simply IL square into RTH. You can write IL square into RTH. Otherwise, formula is there, right? VTH square divided by 4 times RTH. How much we have got VTH? VTH we have got it as 8.33. whole square divided by 4 times RTH, 6.67. So 6.67 into 4, 8.33 square divided by answer. If I do it, I am getting it as around 2.6 watts. 2.602 watts. So 2.6 watts. So this is matching. So option C is matching. Okay. Right. We'll see this question. 3 similar resistors are connected in star across 400 volts, 3 phase lines. The line current is 5 amperes. The value of line voltage should be changed to obtain the same line current with the resistors connected in delta. So initially we have a star connection like this with a line voltage of 400, line current of 5 amperes. Okay. Now the same resistors are arranged in delta and he wants to maintain the line current as same 5 amperes. Now he is asking to maintain the same 5 amperes line current, what should be the value of this line voltage? Line voltage and phase voltage both are same na? Line voltage, phase voltage both are same na in the delta connection. Now let us solve that one. How do you get that? Let us see. If you wanted to find out this resistance, you can calculate resistance also, because line current, phase current, you know it. Anyhow, any power consumption? No, he did not mention. So let us take up. Voltage across a phase is going to be 400 by root 3. There is my phase voltage. What is the phase current in star connection? Same as line current. Now can't you calculate resistance per phase? Resistance per phase will be phase voltage divided by phase current. So this is my resistance per phase. So it could be around 230.94 divided by 5. We will be getting it as around 5 4s are 20, 5 comes out as 16. 230.94 divided by 5. I am getting it as around 46. 46.18 ohms. So the same resistance I am keeping here. 46.18 ohms. 46.18 ohms. Here also 46.18 ohms. And he is saying that the same current drawn by the delta connection, same line current drawn by the delta connection. What will be the per phase current in the delta connection? Per phase current in the delta connection will be line current divided by root 3 na? Our line current is equal to root 3 times the per phase current. So if you do this, 5 by root 3. Okay, I have got a per phase current, I have got a per phase resistance. Now can't you calculate the per phase voltage? So the per phase voltage is equals to, phase current will be 5 by root 3. Phase resistance, how much I have got? 46.18. 46.18 into 5 divided by root 3, if I do so, I am getting it as around 133.33. So 133.33 ohms. You need to apply. So if you can apply 133.33 volts, so the current drawn by the delta connection is going to be still 5 amperes. He is not expecting the same power consumptions, be careful. He is not expecting the same power consumptions. So don't try to equate the power consumptions and don't do that. Power consumptions are not same. He don't wanted to maintain the power consumptions. He wanted to maintain current values, same current values. So the voltage applied is 133.33. Okay, right. Thank you.
I am going to discuss the control systems pre-gate questions. So first one, the block diagram of the control system is shown in figure. The transfer function C of S by R of S is C of S by R of S equal to. So here there are two forward paths are there. One forward path is straight like this, and second forward path is through 1. And there are 4 loops are there. Here this feedback path 4 gives the loop 1 and as well as loop 2. Then this unity feedback gives loop 3, loop 4. So write the first forward path again. What is the first forward path again? 1 by s into 3 by 3s. 1 by s into 3s is the first forward path. To this all the loops touching, plus second forward path. What is the second forward path? Second forward path is here 3 by s. 3s second forward path. Yes or no? 1 into 3s. 3s divided by loops 1 plus opposite sign of first loop gain 4 by s. Opposite sign of second loop gain plus 4. Opposite sign of third loop gain. Third loop gain is what? 1 by s into 3s means, so ss cancel means plus 3. Opposite sign of fourth loop gain like this. So what is the fourth loop gain here? Plus 3s. 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 Then simplify this. What you are getting? ss cancel. Here you will get 3 plus here 3s divided by, if you take LCM here, it will become 3s square plus here it will become s plus 4s plus 3s plus 4. 3s plus 4. Yes or no? So then this s goes to the numerator and into s. Then if we solve this, what you are getting? 3s, take it common. Then we will get what? s plus 1 divided by denominator 3s square plus 3s square plus below here 3s square plus here 3s 4s 4s plus 8s plus 4. So the answer is what? 3s into s plus 1 by 3s square plus 8s plus 4. So it is answer D. The answer is D. Next. So here a linear time invariant system characterized by homogeneous state equation given. State transition matrix is. So you have to find the what? STM. You need to find the STM. So find first you write it Si minus A. You write it Si minus A. So first write STM you have to find. Solution. STM you have to find. So what is the formula? Pi of t equal to what? E power at. That equal to what? Laplace inverse of Si minus A inverse. That equal to Laplace inverse of adjoint of Si minus A divided by what? Det of Si minus A. Det of Si minus A. First write it what? Si minus A. First write Si minus A. So if you write Si minus A, so add S diagonally, na? You should add S diagonally. Opposite sign of coefficients if you write. First one what is there? 0, minus 1. So here 0, here minus 1, here it is what? Here it is plus 1 plus 2. So that means 1, here it is plus 2. This is what? Si minus A. Adjoint you write, adjoint of Si minus A. Adjoint of Si minus A if write. So what you will get here? Tell S plus 2, here plus 1, here minus 1, here yes. Here yes. So now find the STM. So pi of t equal to Laplace inverse of, so here adjoint S plus 2, here 1, here minus 1, here it is S divided by det. What is det you are getting? S square plus 2S plus 1. S square plus 2S plus 1 divided by S square plus 2S plus 1. S square plus 2S plus 1. So then you write inverse Laplace transform apply, L inverse of, what I can write here? S plus 1 we can write denominator, S plus 1 whole square. Here we can write 1 by s plus 1 whole square. Here you can write minus 1 by s plus 1 whole square. Here you can add plus 1 and minus 1 divided by what? S plus 1 whole square. Apply inverse Laplace transform. You will get the answer is what? Here you will get the answer t, I will write it 1 plus t into e power minus t, e power minus t. Then here minus t e power minus t. Here 1 minus t e power minus t. This is the answer. That means what is the answer here you are getting? I think answer is C. Answer is C. Next, so the open loop transfer function of a unity feedback system given, critical damped mentioned, steady state error 0.5 given, the value of k and tau r. So here first find closed loop transfer function. First find closed loop transfer function. What is the closed loop transfer function? K by s square tau plus s plus k. Divide with tau, then what I am getting? K by tau divided by s square plus s by tau plus k by tau. Compare with standard form. Compare with standard form. What is the standard form of second order system? Omega n square by s square plus 2 zeta omega ns plus omega n square. Compare these two. Get it omega n. What is omega n? Tell. Omega n equal to root of k by tau. Root of k by tau radians per second. So 2 zeta omega n equal to what? 2 zeta omega n equal to what? 1 by tau. 1 by tau. 1 by tau. 2 zeta omega n equal to 1 by tau. So now zeta is given here. Is given zeta. Read the question. Critical damped system is critical damped mentioned. That means what is zeta? Tell. Zeta equal to 1. So that means what you are writing? 2 into 1 into omega n equal to 1 by tau. So what is omega n? Tell. Come on. 1 by 2 tau radians per second. So here 1 by 2 tau omega n, here both make it equal. That means 1 by 2 tau equal to what? Root of k by tau. Square it. If you square it, what I will get? 1 by 4 tau square equal to what? K by tau. So now 1 tau is cancelled. That means k equal to what? Tell. 1 by 4 tau. K equal to 1 by 4 tau. This is equation number 1 you take. The second data what is given? So steady state error is 0.5 given. Steady state error given 0.5. ESS equal to 0.5 given for what? Unit ramp input. Unit ramp input. Unit ramp input. So first find kV. You find first what? kV you find. First find kV. kV equal to what? Limit s tends to 0, s into g of s. That means limit s tends to 0, s into what is g of s? K by s into s tau plus 1. So ss cancel, s tends to 0. That means kV equal to k. Then steady state error equal to what? A by k. Unit ramp input mentioned. That means ESS equal to what? 1 by k. Equal to what? 0.5 given. That means k equal to what? 2. The answer is k equal to 2. The answer is k equal to 2. And now find tau value. So 2 equal to what? 1 by 4 tau. So tau equal to what? 1 by 8 means 0.125. Tau equal to 0.125. So 2 comma 0.125. Answer C. Next question, the open loop transfer function of a feedback control system given. With respect to root locus diagram, which of the following is correct, they are asking. So here find centroid, angle of dip, asymptotes, and then breakpoint, all this we have to check it. So if you draw the root locus diagram here, so pole locations if you take it, so G of S, H of S given as what? Tell? K by S into S square plus 6S plus 12 is given. Represent the poles and zeros in the S plane. So one pole at what? Origin, another pole at where? -3. -3 plus J root 3 and minus J root 3. K0, K0, K0. So first you check it what? Centroid. Centroid equal to sum of real part of the poles minus real part of the zeros divided by P minus Z. What is the real part of pole? -3 minus 3. No zeros divided by P minus Z is 3. So that means centroid is -2. Centroid -2. Next, what you have to check? First one, centroid. Angle of asymptotes. Here, number of asymptotes 3. N equal to P minus Z. So, P minus Z. 3 minus 0 equal to 3. So, angle is what? When Q equal to 0, you will get 180 by P minus Z means 3. Means 60. So, next angle 180. 3 asymptotes now 180, 300. That means angle of asymptote 60, 180, 300. Next, what you have to check? Based on the options, you should check it. Next, breakpoint. Find the breakpoint. Breakpoint means simply differentiate. dk by ds equal to 0. So, differentiate it d by ds of given function if you take 1 by s cube plus 6s square plus 12s equal to 0. Differentiate it u dash 0 minus u into. So if you solve this, 3s square plus 12s plus 12 equal to 0. Then s square plus 4s plus 4 equal to 0. That means what? S plus 2 whole square equal to 0. Breakpoint is what? S equal to -2. Breakpoint is -2. So it lies on the what? Root locus branch. -2 is lies on the what? Root locus. This is here root locus branch exists. So here breakpoint. This -2 is a valid breakpoint. That means what are the options correct here? Centroid -2 correct. The second one wrong. Third one C is correct. D is wrong. So that's all. Thank you. Here the closed loop transfer function of the system given. Number of poles on j omega axis are they asked. So directly given closed loop transfer function. Then we can write the directly characteristic equation. So denominator is a characteristic equation. That is s power 5 plus 7 s power 4 plus 6 s cube plus 42 s square plus 8s plus 56 equal to 0 is the what? Characteristic equation. So now you write the Routh array. This is s power 5, s power 4, s cube, s square, s power 1, s power 0. So first coefficient 1, alternate is 6, alternate is 8, next 7, alternate is what? 42, next alternate is what? 56, alternate 56. Here we can divide with what? 7. So 7 1 ja, 7 6 ja, 7 8. So then again do the s cube coefficient, you write 1 into 6 minus 1 into 6 means 0. Again 8 minus 8 0. So here 0. We are getting what? 1 time row of 0. 1 time row of 0. Then we need to form the what? Auxiliary equation. Form the auxiliary equation. What is auxiliary equation then? auxiliary equation is, so 1 into s power 4 plus 6 s square plus 8 equal to 0. So differentiate it, differentiate auxiliary equation with s, then 4 s cube plus 12 s. That means s cube coefficient replaced by 4, then s square coefficient replaced by 12. Again, I can divide this with 4. If you divide with 4, 4 1 ja, again 4 3 ja. Then again what we are getting? 1 into 6, 6. 6 minus 3 become 3. 3 by 1 means 3 only. This 8 we can bring into diagonally. So here also 8. Then again what we are getting here? 9 minus 8 become what? 1. So 1 divided by 3. So now you observed it. So below auxiliary, above auxiliary. You divide the Routh tabular form into below auxiliary and above auxiliary. So if you take below auxiliary equation, there is no sign change. No sign change means what? All the poles must lies on the what? Imaginary axis. How many poles? Order of auxiliary equation, fourth order. That means 4 poles compulsory lies on the what? Imaginary axis, because no sign change below auxiliary equation. That means the number of poles on j omega axis equal to 4.
We'll discuss some questions which were asked in pre-gate examination from the subject electrical machines. So here I have a question like this. A single phase 900 volts by 300 volts 18 kVA 2 winding transformer is reconnected as 300 volts by 600 volts auto transformer. Then he is asking its capacity will be dash kVA. So he has given a 2 winding transformer and is asking that what will be the new rating of the auto transformer if the 2 winding transformer is reconfigured as auto transformer. He has given the voltage ratings of auto transformer also. He has given the voltage ratings of auto transformer also. So here kVA rating will be depending upon voltage and current. He did not mention whether it is maximum kVA rating or minimum kVA rating. Directly has mentioned the voltage rating. According to that he is asking. So anyhow voltage rating values are known. Now you need to find out the current ratings. Okay. So in order to find the current ratings, you need to check the current carrying capacities of 2 winding transformer windings. Okay. So what is the current carrying capacities of 2 winding transformer? It's a 18 kVA and 900 volts, 300 volts. So this is my high voltage winding and this is my low voltage winding. So I can calculate the current carrying capacity of high voltage winding as kVA rating 18 kVA divided by high voltage winding voltage, that is 900. So if you solve it, you will get it as probably you will get it as 180 by 9, you will get it as 20 amperes. Similarly, if you solve for low voltage winding current carrying capacity, it will be 180 by 10 to power 180 into 10 to power of 3 divided by voltage is around low voltage winding voltage is 300 volts. Voltage is reduced by 3 times, current will increase by 3 times. So definitely you will get it as 60 amperes, because apparent power rating will be same on both the sides of the transformer, because transformer is a constant apparent power transfer device. So even you do this calculation also, you will get 60 amperes. So I got a current carrying capacities of each and every winding. Then let us reconnect the 2 winding transformer as auto transformer according to this given voltage rating. So if you reconnect, this will be the situation, okay, or this will be the reconnection, 300 by 600 volts. If you want to get 600 volts, it must be series subtractive polarity. The connection must be series subtractive polarity. Series subtractive polarity. Okay, right. If you add it, then it will be 300 plus 900, it comes out as around 1200, but I want only 600 na. So plus 300 minus 900, you will get it as minus 600 volts. So 300 volts input voltage is 300 and output voltage is 600. So this is my load where I can connect. This is where I can connect the load. What is the voltage across the load? It should be 600. Now I need the rating of this connection. How do you calculate rating? Voltage rating into current rating, na? So load voltage into load current will be the load kVA. Load kVA and source kVA will be same. That means what, I on the secondary side, on the primary side, the kVA rating will be same, na? So if you can calculate the current carrying capacity, or if you can calculate the current flowing through this 900 volts winding, then the current into this 600 volts, you will get the value. Okay, right. Generally, we got a current value on high voltage winding as 20 amperes. So the current carrying capacity of this high voltage winding as 20 amperes and low voltage winding as 60 amperes. Okay, right. So the current should enter at the dot. On the secondary side, the current should leave at the dot. So on the same note, the current should leave the dot like this. On the secondary side, the current should leave the dot. So how much current it is? 20 amperes. So I have 600 voltage and I have current as 20 amperes. 600 into 20 amperes current. So load rating will be, load voltage is 600, load current is 20. You will get it as 6 to the 12 kVA. Even you check on the primary side also. What is the current carrying capacity of 300 volts winding? The 300 volts winding current carrying capacity is how much? It should be, as it is primary, na? So it should be, the current should enter here. So how much it is? 60. Right. So if 60 is leaving like this, then what should be the current should enter at this point? 40 amperes. So 40 plus 20, it becomes 60. So 300 into 40, you will get it as, 300 into 40, you will get it as, on the source side also, you will get it as 12 kVA. So out of given options, the best possible option is going to be this one. And remember, as it is series subtractive polarity, definitely the rating may decrease. The rating may decrease. So be careful about that one. Okay. So 12 kVA is a probable answer. Now we'll see one more question. I have a question like this. A 4-pole wave winding or wave connected DC separately excited generator supplying 20 amperes at 240 volts to a resistive load. If there are 160 conductors in the armature with a resistance per turn of 0.02 ohms, then he is asking EMF induced in the armature is dash volts. He is asking EMF. If you draw the equivalent circuit of separately excited DC generator, whether it is generator, generator, it looks like this. This is how the approximate equivalent circuit of separately excited DC generator. He is asking EMF, this one. Can't you write a KVL equation? If you write a KVL equation, you will get the answer. So EG is equals to what? Terminal voltage plus this drop. Terminal voltage plus armature resistance drop will be the answer. So I can write EG is equals to 240 plus 20 into armature resistance. Now what is the armature resistance value? He has not mentioned armature resistance as 0.02. He has mentioned the armature conductors, number of armature conductors, and he has mentioned the resistance per turn he has mentioned. So be careful while calculating the armature resistance. Moreover, he has mentioned wave connected armature winding. If it is a wave connected armature winding, the number of parallel paths will be equals to 2 only, no? Number of parallel paths will be equals to 2 only. So there are 160 conductors. If 160 conductors are there, in one path I have to place 80 conductors, in another path I have to place 80 conductors. So totally 860 conductors we have to place, or otherwise 40 turns, 40 turns. Conductors, instead of saying in conductors, you can call it in terms of turns also. So number of turns will be how much? Number of turns will be total conductors divided by 2. You will get it as 80 turns. Now this 80 turns has to be arranged in 2 parallel paths. So you will get it as 40 turns on this side and 40 turns on this side. Each turn has a resistance of 0.02. Each turn has a resistance of 0.02. So the resistance per turn into 80 turns, I will get this as into 80 turns, no, sorry, 40 turns. Let me write it as 40 turns. Here 80 conductors, 40 turns. So 0.02 into 40. So you will get this as around 0.8 ohms. 0.8 ohms in one path. There are two parallel paths. If there are two parallel paths, I can say that this parallel path resistance is going to be 0.8 and this parallel path resistance is going to be 0.8. So as they are connected in parallel, their equivalent resistance will be how much? Their equivalent resistance is going to be 0.4 ohms. This is the total equivalent resistance of the armature. This is the total equivalent resistance of the armature. How much it is? 0.4 ohms. So you substitute the resistance value 0.4 ohms. So you will get it as 240 plus 20 into 0.4. You will get it as 248 volts. So the answer is going to be 248 volts. And remember here, the generated voltage is going to be, the generated voltage must be greater than 240, no doubt at all. Yes or no? Because terminal voltage plus drop should be obviously greater than 240. How much will be the drop in the armature resistance? It's very minimum only. It won't exceed more than 10 volts, more than 20 volts also. If you add 10, 240 plus 10, 250. So it will be in the range of 240, it will be in the range of 250, 255 like that only. Because the current value we know anyhow it is 20 amperes. The resistance won't be more than 1 ohm, right? Armature resistance. If it is not more than 1 ohm, even you take it as 20, it comes out as 260. So the answer should be in the range of 240 to 260 only. Be careful. So don't go beyond that. Anyhow, you don't get any negative marks for this one. So be careful with this kind of questions. Okay. We'll see one more question. The question is given as like this. A 3-phase 400 volts line to line 6-pole 50 Hz star connected synchronous motor has a resistance and reactance of 0.5 ohms and 4 ohms per phase. Okay. Now he has given that the motor is drawing an armature current of 15 amperes at unity power factor and is asking the induced back EMF per phase, the induced back EMF per phase in volts will be dash. He has given a synchronous motor and he has mentioned that the armature winding resistance and reactance also. He has mentioned the line current, something armature current also he has mentioned, and it is drawing at a unity power factor. Anyhow, it is star connected, no problem. Okay. So if you see the equivalent circuit of synchronous motor, probably it looks like this. The resistance and the reactance and the induced EMF at an angle of delta. Single line diagram. He is asking EMF. He has given the voltage. As it is a single line diagram, you can take a per phase manner. So as it is, if you want to write in terms of per phase manner, as it is star connected, you can write in terms of 400 by root 3. So this is a per phase value. These are also per phase value, 0.5 ohms and 4 ohms. So terminal voltage or the supply voltage, I can say, supply voltage minus drop is equals to EMF or not? Supply voltage minus impedance drop, armature winding resistance drop or armature impedance drop is equals to EMF. Okay. Either you can do like that or otherwise the EMF equation from the phasor diagram you can get like E square is equals to V cos phi minus IA RA whole square plus V sin phi plus minus R plus IA XS whole square. In that manner also you can do. As it is motor, because as it is motor, the current direction should be into the motor. Generally most of the people will remember generator equation, and for motor if you forget to replace the sign with the negative, if you forget to replace the current sign as negative, then gone case, you don't get the answer. Okay, so be careful. So this is what I am speaking about. Okay, either you can do this one or you can do this one. Most of the people will go ahead with this one, no issues. You can go ahead with this one or you can go ahead with this one. But I prefer, what I prefer is, whenever the power factor is unity, so the current phase angle is going to be 0, no? The current phase angle is going to be 0. Therefore, this equation will give you the quick answer. No problem. This equation will definitely give you the answer very quickly. Right. So let me solve by doing this one. So what all these terms are per phase values only. So what is a per phase voltage? 400 by root 3. It comes around 230.94, I believe. Okay. So 230.94 minus IA RA. What is the armature current? He has mentioned it as 15 amperes. As it is star connection, line current, phase current, both are same or not? Yes, both are same. So I can write 15 amperes. What is the armature resistance? 0.4 ohms. 0.4 or 0.5? Sorry, 0.5 ohms. Let me write it as 0.5 minus J IAXS 15 into what is the synchronous reactance value? 4 ohms. On the right side, you can take up it as E at an angle minus delta. So you can solve this one. If you solve this one, 15 into 0.5, 7.5. So 230.94 minus 7.5. So 230 minus 7 comes out as around 223. It will be around 222 something approximately. Let me write it as exactly also. 230.94 minus 7.5. I am getting it as around 223.44. Minus J 15 4s are 60. I want E, magnitude of induced EMF, right? I want E, magnitude, the induced EMF per phase also. He is asking in per phase manner only. So what is the magnitude? We have in terms of x plus or x minus iy format. So let us take up magnitude of E. Magnitude of E is equals to 223.44 whole square plus 60 square. So if you do this one, probably it will be very near to that per phase supply voltage only. Per phase supply voltage only. So let me do that one. So 223.44 square plus 60 square is nothing but 3600. If I do this one and if I apply root, I'll get the answer. I'm getting the answer as around 231.35 volts. So this is the magnitude of induced EMF I'm going to get. If he is asking power angle, or otherwise the delta load angle, then tan inverse of this tan inverse of minus 60 divided by 223.44, if you do it, it will be around 12 or 16 degrees, around like that you'll get. Okay, anyhow, this is the answer. Remember here he has mentioned unity power factor. He has mentioned that unity power factor. If you neglect armature resistance, generally the phasor diagram will be like this, no? Supply voltage, the current will be in phase with the supply voltage IA, and if you neglect the armature resistance drop, V minus the what is the remaining drop? V minus JIAXS. V minus JIAXS. So this is my IAXS drop and this will be my induced EMF E. The angle between E and V is going to be delta. Now, if you see the height of the induced EMF, this will be E cos delta actually. So the E cos delta is approximately equals to the supply voltage. The height of this EMF phasor, that is E cos delta, is approximately equals to supply voltage. What is the supply voltage value? Around 230 point something 94. What is the induced EMF you got? Around 231.35. You see, from the phasor diagram also we can conclude approximately the induced EMF magnitude is going to be more or less near to the supply voltage. Little variation is there. So in that way you can choose at least nearby values. Okay. So the answer is here 231.35 volts per phase. All right. We'll see one more question. A 3-phase 4-pole delta connected 440 volts 50 Hz induction motor is driving a load at 1460 rpm and its load torque is proportional to its speed, and is asking that if it is required to drive the load at 1160 rpm and at 40 Hz supply, then the supply voltage to be reduced to what value? So it is clear that the given induction motor is operating from or is operating at variable voltage, variable frequency control technique. So the voltage to frequency ratio must be maintained as constant, na? The voltage to frequency ratio must be maintained as constant. Otherwise, what will happen? The rotating magnetic field is going to change and it leads to change in magnetizing current, and it will result in other consequences like heating effect and magnetic inrush current and all those things. So you have to check voltage to frequency ratio. So let me check voltage to frequency ratio. V2 by F2 is equals to V1 by F1. V2 is how much? Let me take up directly line voltage 440. F1 is how much? 50. F2 is how much? 40. So if you do so, the line voltage or something voltage, you will get it as 440 divided by 50 into 40. So you will definitely get it as less than 440 only, 352. So if you look into the options, nothing is matching, but something is nearby 352, that is 340. Most of the people will go and select this answer, but this is absolutely wrong. This is valid only when the load torque is constant. When he says that when the load torque or when the induction motor is driving a constant load torque. When the induction motor is driving a constant load torque, then this is true. But he is saying that the load torque is proportional to speed. Proportional to speed he has mentioned. Okay, so what will you do now? So now the load torque is proportional to speed. So load torque definitely has to met by the electromagnetic torque, motor torque na. So you can replace this electromagnetic torque, load torque with electromagnetic torque and write this one. Now you need to calculate the electromagnetic torque produced in the second case when you apply a frequency of 40 hertz. The electromagnetic torque produced in the first case when you apply a frequency of 50 hertz. And N2 how much speed he wants to run? He wants to run at 1160. N1 how much speed it is running at? 1460. Now you need to take care about the electromagnetic torque equation. What is the electromagnetic torque equation? 180 by 2 pi ns into S into E2 square by R2. So in that slip can be replaced by the per unit slip can be replaced by ns minus nr divided by ns, like that. So if you replace that, and you can write the electromagnetic torque as proportional to V by F whole square into ns minus nr. Relative speed. In voltage to frequency, in variable voltage, variable frequency control technique, relative speed must be same. Then only electromagnetic torque will be same. Yes or no? So you will get an equation, you will end up with an equation like this. Alright. So I can replace this now. V2 by F2. V2 I do not know. F2 40. Now what is NS2? What is NS2? NS2 is the synchronous speed produced at 40 hertz supply. 120 into 40 divided by how many poles are there? 4 poles are there. So 4 3s are 12, and I think it is going to be 1200 RPM. 1200 RPM. NS2 is going to be 1200. What is NR2? 1160 has given. You see the relative speeds, it will be same only. V1 is 440. F1 is 50 square into NS1. What is NS1? NS1 synchronous speed with 50 hertz. 120 into 50 is going to be 6,000. 6,000 divided by 4, you will get it as 1500 RPM. So 1500 RPM. What is NR1? Initially, the load is driven at 1460 RPM. Is equals to, it must be equals to the speed, it must be proportional to speed changes. So N2 is of 1160 divided by N1 is of 1460. So I am writing just it as 1160 as 116, 146, like this. You see here, what is the relative speed? 1200 minus 1160, 40. 1500 minus 1460, 40 only. So the relative speeds are constant, the relative speeds are same. So you can eliminate them. So I can write now V2 by F2 whole square is equals to 116 divided by 146 into 440 by 50 or 444 by 5 whole square. So you do this one. If I do this one, 44 by 5 square of it into 116 by 146, I am getting this as around 61.52. If I apply a root, for this one, I am getting it as around 7.84. So V2 by 40 value, I am getting this one. So what is a V2 value? 7.84 into 40, I am getting it as around 313.75 volts. So you can approximate it as 314 volts. So the voltage is going to be 314 volts approximately. So be careful about this kind of questions. Most of the people will go ahead with this one and they'll end up with this kind of answer. No, no, no. And they'll choose 340. Please don't do that one. Be careful. What is the information he has given? Whether he has mentioned load torque as constant or not. Okay, be careful. We'll see another question. A 220 volts DC series motor with a total resistance of 0.4 ohms is rotating at 1820 RPM by drawing a current of 20 amperes. Now, is asking if its load torque is proportional to its speed. Load torque is proportional to its speed. And if it is required to operate the motor at 1460 RPM, if it is required to operate the motor at 1460 RPM, then the additional resistance to be placed in series with the armature is dash ohms. He is reducing the speed from 1820 RPM to 1460 RPM. Now, how much extra resistance you need to place in the armature resistance or in the armature circuit is asking. So, definitely you look at the first case and you look at the second case, and remember that load torque is proportional to speed. Moreover, it's a series motor. Be careful, it's a series motor. If it is a series, generally any motor for that matter, any motor, torque is proportional to what? T is equals to K phi Ia na. If it is a series motor, the flux produced in the field winding is proportional to armature current. So I can replace the flux with armature current and we can write it as K into Ia square, or simply torque is proportional to Ia square. As he has mentioned that the load torque is proportional to its speed, I can replace the torque with speed. So now N is proportional to Ia square. So as the speed changes, definitely the current changes, no doubt at all. In the first case, it is drawing 20 amperes and running at 1820. In the second case, it will draw some other current and running it is going to run at 1460 RPM. So you can find out now, N2 is 1460 divided by N1 is 1820 is equals to Ia2 divided by Ia1. Ia1 is of 20. So we have a square here. Let me bring on to the left side. I am writing it as root. So if you apply a root, 146 divided by 182, and if you make a root of it, and I am getting it as around 0.89. 0.89 into 20, I will get it as around 17.91. So the series motor is going to draw around 17.91 amperes in the second case when you put a resistance, some external resistance in series, and it will run at 1460 RPM. He is not asking this value, he is asking what is the amount of extra resistance you will put in the circuit is a question. So how do you calculate that one? From the EMF equation. Use KVL, you will get it. What is the EMF equation? What is the EMF equation? The EMF equation we generally write it as E is equals to K phi omega na. Anyhow, K is a motor constant, you just replace it. E can be replaced with phi, I am replacing with armature current and omega. Phi I am replacing with armature current and omega. So I need to calculate E2, E1, Ia2, Ia1, N2, N1. I know the speeds N2 and N1. I know Ia2 also. I know Ia1 also. Ia2 how much we have got? 17.91. Okay, you substitute E2 equation, you write KVL, you will get it. So let me write that E2 has 220 minus current into this resistance. 220 minus 17.91 into this total resistance will be external resistance plus 0.4 divided by E1 is of, E1 how much you are going to get? E1 will be 220 minus current into resistance, 20 into 0.4 you will get 8, 220 minus 8, 212. So I am going to get it as EB1 as around 212 volts. And on the right side what I have? I have current and speeds. So Ia2 is around 17.91, Ia1 is around 20, and N2 is how much? 1460, and N1 is of 1820. So I am writing it as 182. So from this you need to solve the resistance. Probably you can get this one. So 17.91 into 146 divided by 20 into 182. I am getting on the right side, I am getting it as 0.718 into 212, 152, 220 minus 152, 67 by 17.91 and minus 0.4. So I am ending up with, after solving, I am ending up with the external resistance as around 3.38 ohms. So this is the external resistance I am ending up with. Remember, the numerical type questions doesn't have any negative marks. You can try, so you can attempt this one. Okay, so be careful. Generally, most of the people will try to solve with this one, and they'll not get the answer. So be careful. In the question, the one more relation also he has given. The torque is proportional to speed. So you just replace that. As a torque is proportional to speed, in the question it is mentioned. So you replace the torque with N and go ahead and solve the current value. Okay, I hope it is clear. We'll see another question here. A 3-phase 90 kVA star delta connected transformer has a phase turns ratio of 4.5. Phase turns ratio of 4.5. With the input line current of 30 amperes, the output line voltage is dash volts. Output line voltage is nothing but what? Input is star, output is delta. So he is asking this line voltage. He is asking this line voltage. Input line current he has mentioned, no? Input line current he has mentioned. Output line voltage is asking. So how do you calculate this voltages? He has mentioned some phase turns ratio, he has mentioned some rating also, he has mentioned some current also. So from the rating you can say the apparent power on the primary side and apparent power on the secondary side will be same, na, because it is a transformer. Transformer is a constant apparent power device. So I can say that here √3 into VL into IL. I know the line current, input line current. What is that? 30. What is the voltage? We do not know. What is the rating he has mentioned? He has mentioned that it is a 90 kVA. So if I solve it, probably 3 divided by √3. So VL is equals to 3000 divided by √3. 3000 divided by √3 you will get 3000 by divided by √3. So this is the line voltage on the star connection. What is the per phase voltage? What is the per phase voltage? Per phase voltage on the star connection will be line voltage by √3, na? Per phase voltage will be line voltage by √3. So already line voltage is 3000 by √3. Now divided by one more √3, you will get it as 1000, right? Because 3000 by 3 you will get, so you will get it as 1000 volts. So the voltage on the per phase, voltage on the star connection side, the per phase voltage is going to be 1000 volts. Now from that relation or from that voltage, you can get the voltage on the secondary side. How? Use this phase turns ratio. Phase turns ratio is nothing but N1 by N2. N1 per phase by N2 per phase is equals to V1 per phase by V2 per phase. So you can get it, no? Same thing, whatever, this is what I tried to put here. Now V1 per phase I know it is 1000. Now V2 per phase you need to calculate. So V2 per phase is equals to how much? 1000 by 4.5. 1000 by 4.5. It is coming out as around 222.22 volts. Okay. So this is the voltage on the on the output side. What is the line voltage, by the way? As it is delta connection, line voltage, phase voltage both are same. So I can write it as 222.22. He has mentioned give up to or rounded off up to 2 decimal places. So you can round it off up to 0.22 or 0.23, that is fine. 23 is not good, but 0.22 is okay. 222.22. Okay, so that is the voltage on the secondary side of the transformer, given transformer. Okay.
Hello friends, let us solve the pre-gate questions 2025 exam conducted by ACE Academy from the electrical paper. Okay, right. What will be the output of the following circuit if point P is locked or stuck at logic 1? So this node is stuck at 1. Simple. If exclusive OR gate, one input is logic 1, whatever may be the second input, let us assume this is X, then what will be the output? X XOR operation with 1, output is X bar. So what is the X that you are going to find? It is basic logic gates question. If, anyways, C is 1. So 1 dot B bar, output of the AND gate, bubble AND gate of course, is B bar. This is A XOR B. A XOR B. Then what will be the X value now? X is equals to XOR operation between B bar and A XOR B. So X is equals to A XOR B XOR B bar. We can do XOR operation here only, right? And then you can pass the result through NOT gate. This is like a NOT gate. XOR operation with one input as 1 means it is acting as a NOT gate. Or otherwise, after completion of the equation passing through this logic gate, you can simplify. Okay, you can choose any method, no problem. You know well, P XOR Q bar is equals to P XOR Q. So similarly, assume this is K and P, K XOR P bar, K XOR P. So that what is the X? A XOR B XOR B. A XOR B XOR B. But what is the output Y? Its complement. So that Y is equals to X bar whole bar XOR complement XOR. So that Y is equals to A XOR B XOR B, and Y is equals to A bar B. For example, assume this as X and Y, X bar Y plus X Y bar. X bar XOR complement XOR, so that AB plus A bar B bar B plus A bar B plus AB bar X dot Y bar. In place of Y we have B, so you write B bar. Then what is output? B into B bar 0. Simply this portion will give you AB. B bar into B will give 0. This portion will give you B bar dot A or AB bar. So what is the common term here? A is a common term, right? B plus B bar value is 1. So Y naught is equals to A. C is the correct option. See, clear to Q. If the clear is activated, output will be 0, you know well. That action will take 2 nanoseconds. Similarly, if preset is activated, Q will be set to 1. That action also will take 2 nanoseconds. Inputs are connected to ground because clear and preset are, dominating controls. If one of them are activated, automatically output Q will be under the control of that activated terminal. Clear activated, output 0. Preset activated, output 1. Clear and preset are, look at this, active low enable type. If you give 0, then they will activate, right? So assume initially output is logic 0. Assume initially output is logic 0, like this. If output is 0, 0 complement 1. So, clear is disabled. But if this is 0, preset is going to enable. If preset is enabled, what will happen? Output will be 1, you know. But output will change from 0 to 1 after some time delay. What is the time delay? 2 nanoseconds. After 2 nanoseconds, output will change from 0 to 1. After 2 nanoseconds, output will change from 0 to 1. Now, output is at logic 1. 1 connected to preset. Preset is disabled now. But 1 complement 0, 0 is connected to clear. Clear is activated. So, output is going to clear. Initially, output is at 1. It is going to clear after another 2 nanoseconds because the delay is 2 nano. After another 2 nanoseconds, output will change from 1 to 0, like that. It is going to produce a square wave. So, what is the total time period? On time plus off time. This is the total time period. So, t is equals to 4 nanoseconds. What is the frequency? F is equals to 1 by t. 1 by 4 into 10 to the power of minus 9 hertz. So, if you calculate it, you will get 250 megahertz, right? Next question. Consider the circuit shown below along with the clock symbol. The values of AB at a time t equals to t naught, 0 and 1. A value is 0 and B value is 1. Got it? Respectively. Then the hexa equivalent of a binary from the nodes A, B, C, D at a t equals to t1. Look at this, man. This flip-flop is actually a rising edge trigger type. At a t naught, he has given the data, some data. At a t1 means after 1 clock pulse, that you have to understand. He is asking the question, the value. First you have to find the binary values at A, B, C and D after 1 clock pulse. Then you convert it into hexa. Initially, look at this. A is equals to, A means output of this box is equals to B XOR C XOR D. This is B, C and D. C and D values are fixed at 1 and 0 respectively, right? And you know this is what? Odd gate. 3 input XOR. This is a odd gate. So, output will be 1 if you find odd number of 1s in the input. If you find odd number of 1s in the input. Got it? So, that what is output here? B value 1. So, 1, 1, 0. Even number of 1s. That is why it has already producing 0. After 1 clock, what will happen? D flip-flop is a transparent flip-flop. After 1 clock pulse, this 0 will transfer to the output. So, that output will be 0 after 1 clock pulse. Simply I am taking the symbol like this after 1 clock. If this is 0, this is the feedback, right? 0, C value 1 and D value 0. This block is receiving odd number of 1s, single 1. Hence, this is going to change into the logic 1. Okay? So, A, B, C, D are the nodes. What is the binary corresponding to those nodes A, B, C and D? A value 1, B value 0, C value 1, D value 0. So, that 1, 0, 1, 0. This is in binary. He is asking the data in hexa. A base 16 or AH. H, we have to select A, which is given in option A. Simple and direct question. Right, guys? These are the questions found from this paper.
Given x of n equal to sine pi by 2 n by pi n, the energy of the signal, that is summation n from minus infinity to infinity modulus of x of n whole square is. They gave a discrete time signal, they are asking its energy. So, in the time domain it might be a little difficult. Let us apply the Parseval's theorem and then get the answer. So, what does the Parseval's theorem say? According to Parseval's theorem, so this is a DTFT topic, students. According to Parseval's theorem, summation n from minus infinity to infinity x of n magnitude square is equal to, you have to recollect DTFT concept. So, it is 1 by 2 pi integral minus pi to pi it is x of e power j omega magnitude square d omega. So you have to use this relation to get the energy. Do you people know what's the Fourier transform of this? So what's the Fourier transform of sine pi by 2 n by pi n? This is in the form of sine omega naught n by pi n. It's a standard result, sine omega naught by pi n Fourier transform. Try to recollect this. It's a rectangle, so you have to be a little careful while drawing this. It's like what? A rectangle from minus pi by 2 to pi by 2. So here the height is 1 and this is minus pi. This is pi. We have a habit of drawing the things from minus pi to pi. So from minus pi by 2 to pi by 2, its value is 1. This is x of e power j omega, students. Now use this, you substitute that here, you get the energy. It is 1 by 2 pi. There is no need to integrate from minus pi to pi. You have to integrate from minus pi by 2 to pi by 2 because in this range, for these frequencies it is 1, from minus pi to minus pi by 2 it's 0, pi by 2 to pi it's 0. So to integrate only from minus pi by 2 to pi by 2. In this range of frequencies, what is x of e power j omega? It is 1 square and then d omega. 1 square is 1, d omega integration is omega. Substituting the limits will give you pi by 2 minus of minus pi by 2. So this is like pi by 2 plus pi by 2, which is pi. The pi's will cancel and 1 by 2 will remain. So this is something like pi by 2 pi, students, which is 1 by 2. The answer for this question is option A. Consider a discrete time system for which the input x of n and the output y of n are related through this equation. Y of n is x of n plus 1 by 3 into y of n minus 1. Y of n is 0 for n less than 0. X of n is your discrete impulse. Then y of n can be expressed in terms of unit step u of n as follows. With all this information, they are asking what's the expression for y of n. So take down this reference equation. This reference equation can guide you. Very simple problem. So what's that equation? Y of n equal to x of n plus 1 by 3 y of n minus 1. Let's apply z transform on both sides, and clearly y of n is 0 for n less than 0. What is y of z? Apply z transform. This is x of z. Now you apply the shift property. It is 1 by 3 z power minus 1 into y of z. You don't have any other terms because anyway y of n is 0 for n less than 0. Take y of z to the other side. If y of z is taken common, then what is left is 1 minus 1 by 3 z power minus 1 equal to x of z. They want y of z, and by the way, is the input given? Yes, del of n. Input is del of n. So input is del of n. What's the z transform of del of n? The z transform of del of n is 1. So here what remains is just 1. So the z transform of del of n is 1. So 1 here. When this goes here, only 1 remains. Can you get an expression for y of z? 1 by 1 minus 1 by 3 z power minus 1. This can also be viewed as z by z minus 1 by 3. By looking at these options and looking at the z transform, if I take the inverse, I get y of n as, I know that it is 1 by 3 whole power n u of n. This is clear in the form of z by z minus a, whose inverse is 1 by 3 whole power n u of n. So even though the ROC is not given, you don't have any left sided sequence, everything is in u of n. So the most possible answer is the option B, 1 by 3 whole power n u of n. That's a right answer for this question. Let g of n equal to 1 whenever n is 0, and for all other values g of n value is 0. Okay, this is nothing but our discrete impulse. H of n is 1 for n equal to 0, 3, 6, 9, 0 otherwise. Consider y of n, which is h of n convolved with g of n, where the star denotes the convolution. They are asking what's the value of y of 3. So how do you find the Z transform? So I'll tell you one thing. So y of n equal to h of n convolved with g of n. In this problem, if you use Z transform, it would be very easy. So let's apply Z transform on both sides. In that case, this would be h of z into g of z, h of z into g of z. You have to substitute the respective Z transforms. This is clearly a discrete impulse. This is 0. At 0, you have 1 volt, and for all other values at 0, this is like del of n students, whose Z transform is 1. So g of z is 1. I have no issues with that. H of z. So it's defined at 0, 3, 6, 9. Do you know the definition of h of z? H of z will be like summation n from minus infinity to infinity h of n z power minus n. Since it is defined only at 0, 3, 6, 9, so expand that summation only for those values of n. For other values of n, h of n is 0, the product is 0. So come on, write h of z. It is 1 into z power 0, which is anyway 1, plus 3 z power minus 3 plus 6. I'm sorry. So I'm extremely sorry. This is like this. So it's like 1 plus what is h of 3? H of 3. H of 3 is also 1. Earlier I thought h of 3 is 3. Where is that given? H of 3 is also 1. H of 6 is also 1. H of 9 is 1, and the remaining values are 0. So it's like 1 z power minus 3 students plus. So there is no value at n equal to 4, which means 0, and then you can go to 6 now. So again 1 z power minus 6 plus 1 z power minus 9, this whole multiplied with 1. So what is left is 1 plus z power minus 3 plus z power minus 6 plus z power minus 9 is left. This is y of z. What they asked is, what's the value of y of 3, the time domain signal at n equal to 3. If you know this Z transform, it's easy, you know. You see, Z power minus n coefficient is h of n. Z power minus n coefficient is h of n. Z power minus 3 coefficient will be y of 3. If you still don't get, then you expand y of z definition. Y of z is summation n from minus infinity to infinity. It is y of n z power minus n. So you put certain values, maybe let's put 0, then this is y of 0 plus put 1, this is like y of 1 z power minus 1, put 2 y of 2 z power minus 2, put 3 y of 3 z power minus 3, and so on. So why I'm expanding this is, if you want y of 3, then look at z power minus 3 coefficient in the Z transform. If you want y of 3, look at z power minus 3 coefficient, which is 1. Therefore, y of 3 is 1. This is simple. If you have good basics, you can easily crack this problem. They give a periodic signal 3 cos 2 pi into 100t, this is into not dot, plus 2 cos 2 pi into 300t plus 4 cos 2 pi into 500t. The RMS value of x of t is, clearly this is a periodic signal. Find the average power. The average power is simply, so what we know, the average power half, what is this? It is 3 square plus 2 square plus 4 square. Sir, how did you write this quickly? So this is like, I can say that this is already in Fourier series format, where you have sum of sinusoids. When you have sum of sinusoids, do you know what's the average power formula? Let's say this is in trigonometric Fourier series form. The average power formula is a naught square plus half summation n from 1 to infinity, it is an square plus bn square. So you have all cos terms, you don't have sine terms, leave this. There is no DC, leave this. So this is what is left. So what is the average value, students, now? This is half 9 plus 4 plus 16. Okay. This is 20, 29 29 by 2 is 14.5. Now what do you know about the RMS value? The RMS value is simply the square root of P average, that is 14.5. Use your virtual calculator, see how much is 14.5. So I have calculated and I found that it is 3.807. This is the answer. So once again, how did I do that is, this is, so I, in the background I feel this is like a Fourier series, okay, where the coefficients are there are no sine terms, there is no DC. So don't worry about this, don't worry about bn square, simply summation an square by 2, that's the answer. That's what I have done here. Consider the signal x of t equal to 1 by a square plus t square. The Fourier transform of x of t into sine bt. X of t into sine bt is suggesting use modulation property. So let's see how do we deal with this. Let me first write the modulation property. According to modulation property, x of t into sine bt Fourier transform will be like 1 by 2j. So 1 by 2j x of omega minus b minus x of omega plus b. This will be the Fourier transform. If you can get Fourier transform of x of t, then substitute there. That's why you see the options in the form of all this omega minus b and so on. And I need also j, so I don't worry about a and b. This, like, I can eliminate them. And clearly it looks like there is a print mistake here. There should be a minus sign somewhere in a and b. So either in either in c or d there must be a minus sign. There's a printing mistake here, please correct this. Let me give you the right answer. So let's start. 1 by a square plus t square. I don't know the Fourier transform of that, but I know one thing, e power minus a mod t. The Fourier transform of this is 2a by a square plus omega square. According to the duality property, so let's write like this, 2a by a square plus t square. If you replace omega with t, then the Fourier transform of this will be 2 pi. You have to replace t with minus omega into e power minus a into modulus of minus omega. Modulus of minus omega is same as mod omega. So you can also send 2a to the other side. 1 by a square plus t square Fourier transform is, the 2's will cancel, it is pi by a. It is pi by a e power minus a modulus of omega. So I have got the Fourier transform of a square 1 by a square plus t square. Now this is like x of omega, students. This is like what? X of omega. You have to substitute that into this formula to get the final answer. Let me substitute that into the formula. If I substitute, so let's see what's the answer. It is 1 by 2j x of omega minus b. So that is pi by a e power minus a into modulus of omega minus b minus again pi by a, it is e power minus a modulus of omega plus b this time. So what is common is pi by a, so this is pi by 2aj and then e power minus a modulus of so pi is also common, c power minus a into modulus of omega plus b. So this would be the right answer. Do you have any options this way? Firstly, I have eliminated this, pi by 2aj is there, okay, pi by 2aj is there. So one of them should have a negative sign, so this is the appropriate option. I hope they'll change this, they'll make one of the options as option B, but I gave you the right solution. I hope you do not have any doubts in this. Consider the discrete time system with impulse response h of n equal to -1, -2, 2, 1. Which of the following statements are true about the system? It's a linear phase, it's a non-linear phase, high pass filter, low pass filter. Can you draw h of n? How do you draw h of n? So let me mark, this is 0, this is 0, 1, 2, 3. At these values, what are the h of n values? One is -1, okay, -2, okay, and then this is 2, okay, and then this is 1. Now after drawing h of n, do you see any symmetry about some point, about an integer or a half integer? So I'll show you. Let me draw a line like this. If this is 1, this is 2, definitely this is 1.5. If you see either a symmetry or anti-symmetry, here I can see anti-symmetry. If h of n has symmetry or anti-symmetry, first of all, it's a FIR filter because there are only 4 samples given. For FIR filter, we have a concept which says if there is a symmetry or anti-symmetry, here we have anti-symmetry about this half integer 1.5, definitely it will show linear phase. The problem is over. This is a true statement. But since it's a MSQ, you need to analyze what kind of filter it is. Yes, we will do that. Come on. What is h of e power j omega? The Fourier transform. It's defined as summation n from minus infinity to infinity. It is h of n e power minus j omega n. Expand this summation. So the summation will run from 0 to 3. Summation n from 0 to 3. It is h of n e power minus j omega n, because at only these values you have the non-zero samples. For all other values it is 0. Put this as n as 0. So at n equal to 0, the signal value is -1, e power 0 is 1, plus put n as 1, it is -2 e power minus j omega. Put n as 2, it is 2 e power minus j 2 omega. Put n as 3, so it's plus 1 into e power minus j 3 omega. So we got the frequency response. If you can find the gain at low frequencies and gain at high frequencies, you might get some idea. So let's find the gain at low frequencies. For that, I'll take omega as 0. So when I take the omega as 0, this is -1, this is -2, e power 0 is 1, e power 0 is 1, so this will remain as +2 and this will remain as +1. So this cancels 0. The low frequency gain is 0. Okay, so when the low frequency gain is 0, it cannot be a low pass filter. It cannot be a low pass filter. This is false. Let's find the high frequency gain. For high frequency, we substitute omega as pi. Come on, substitute pi. So this is -1 plus -2 into e power minus j pi. E power minus j pi is -1. Substitute pi. E power minus j 2 pi is 1. So this is +2. E power minus j 3 pi. E power minus j 3 pi. How much is that? It will be -1, students. So there is a cancellation. Is there a cancellation? No. Is there a cancellation? So let's check. This is -1, this is -1, -2. So this cancels, this remains. This is clearly not 0. The high frequencies are allowed, the low frequencies are rejected. Low frequency rejected, high frequencies are allowed. It's a property of high pass filter. This is a true statement. The correct answers are, it's the option A and option C. Let x of s equal to s e power -2s plus 1 by s plus 1 into s plus 2. What's the inverse of x of s? So this problem needs partial fraction. So you need to know a lot of properties. So now what I'll do is, to start with, I'll just assume. So can we separate the terms? S e power -2s by s plus 1 into s plus 2, this will be the first term, plus 1 by s plus 1 into s plus 2. So look at this question, look at the options. Because of e power minus 2s, there will be a shift in time. You all know exponential in S domain leads to shift in time. So because of that, you get e power minus 2 into t minus 2 and then so on. This answers are because of this, and these answers are related to this term. You have to separate, like solve them separately. So maybe I'll first solve this. 1 by s plus 1 into s plus 2, which can be viewed as a by s plus 1 plus b by s plus 2, and then LCM if you take, this is a into s plus 2 plus b into s plus 1. Put s as minus 2, so 1 equal to this is gone. If I put minus 2, I get minus b na. So the value of b is minus 1. Put s as minus 1, this is gone. So minus 1 plus 2 is plus 1, the value of a is 1. So now you have the values of a and b. This is 1 by s plus 1, b is so minus 1 by s plus 2. What will be the inverse of these terms? Come on, check it. What is the inverse of this? It's very easy. The inverse of this will be like e power minus t into u of t, okay, whole multiplication we can do, minus e power minus 2t and then whole multiplied with u of t. So I can eliminate this option because you have a plus sign. I can eliminate this option. So our answers are now within B and C. It's e power minus t and minus 2 e power minus 2t u of t, yes. So one more step, you have to simplify this portion. Let me go to the next page. What we have is s e power minus 2s by s plus 1 into s plus 2. I'll not directly take this into the partial fraction. First, what we will do is we will write like this: s by s plus 1 into s plus 2, because z power minus 2s is like exponential term in s domain which leads to a shift in the time. So we have to do shifting in the time. So let's keep that. So this can be written as a by s plus 1 plus b by s plus 2, s equal to a into s plus 2 plus b into s plus 1. So let's put s as minus 2. So this is minus 2 equal to 0 minus b. So this implies the value of b is 2. Similarly, put s as minus 1. This goes. So here minus 1 equal to a into 1. So the value of a is minus 1. So now I am writing this as the partial fraction. What is a? This is minus 1 by s plus 1, but this has to be multiplied with e power minus 2s plus what is b? 2 by and then s plus 2. This whole thing should be multiplied with e power minus 2s. Now it's time to take the inverse. Don't worry about e power minus 2s. Minus 1 by s plus 1 is minus e power minus t, but in the place of t there is a exponential in the s domain which leads to shift. So let's do it step by step. It's like e power minus t into u of t. I'm not in a hurry. So plus 2 into the inverse of only this is e power minus 2t into u of t. This is not the final answer, intermediate answer. Now the final answer is, because there is an exponential in this domain, there will be a shift in the time. So where I have to replace t with t minus 2 minus e power minus of t minus 2 u of t minus 2 plus 2 e power minus 2 into t minus 2 u of t minus 2. So C is this option available. Like we said, our answer is between B and C. Okay. So in this there is a plus, but we got a minus term, I think. Yes. So this is eliminated now. Now you can check it. Is our answer matching everything? Yes, it is matching 2 e power minus 2 into t minus 2 minus e power minus of t minus 2 and then whole multiplied with u of t minus 2. Yes, this fits into the problem. The answer for this is option B. It's a very good question.
Pre-gate analog circuits solutions now. Go through the question once. Neglect the channel length modulation. The MOSFET given are similar and have a transconductance GM. Calculate the voltage gain. Go through the question. Now, the given MOSFET are similar. Similar meaning both have the same GM, and since the channel length modulation is neglected, you can neglect R naught. You can neglect R naught. So, voltage gain is a AC parameter. Voltage gain is a AC parameter. So, let us draw the AC equivalent. For AC equivalent, we have to kill the sources. The DC sources are removed here. Current sources are replaced by open circuit, and voltage sources are replaced by short circuit. Okay, so this Vn is distributed as VGS1 and VGS2. And here you have ID1 and ID2. So this is the AC equivalent. Now we are asked to find V0 by Vn. There are two ways. One is you can do by the small signal model, or directly you can write the Kirchhoff's laws. You can write the Kirchhoff's laws. But before we write Kirchhoff's laws, try to understand that in a differential amplifier, there is symmetry. Symmetry meaning this VGS1 is minus VGS2, the ID1 is minus ID2, So VGS1 equal to minus VGS2 equal to VGS, and ID1 equal to minus ID2, you can treat it as ID. So let us write Kirchhoff's laws now. So what is ID2? ID2 is 0 minus V0 by RD. ID2 is 0 minus V0 by RD, or V0 is minus ID2 into RD, or minus ID RD. V0 is minus ID RD. What is Vn? Vn, if you apply KVL, Vn is minus Vn plus VGS1 minus VGS2 is 0. So substitute VGS1 equal to VGS minus VGS2 as VGS. So Vn is 2 VGS. So if you do V0 by Vn, you will get the solution. If you do V0 by Vn, you will get the solution. Now you can see minus ID2 is nothing but plus ID. Minus ID2 is nothing but plus ID. So take the ratio V0 by Vn. V0 by Vn is ID RD by 2 times of VGS. 2 times of VGS. So what is ID by VGS? It is GM. GM by 2 times of RD. This is the voltage. So let me, or you can replace the MOSFET by the small signal model and do it. But if you know that in AC analysis, ID is GM times of VGS, then just by writing Kirchhoff's laws, you can do it. Or otherwise, it is a simple problem. If you take left side, the gain is minus GM RD by 2. If you take right side, it is plus GM RD by 2.
If you take the difference, it is going to be minus GMRD. If you take the difference, now this is taken as the single-ended output. So it is going to be half of the total differential output. So the differential output is minus GMRD. This is plus GMRD by 2. So option D is the solution. Option D is the solution to this problem. Okay. Now, let us go for the second problem. The transconductance of the MOSFET is GM and the small signal drain to source resistance due to the channel length modulation is R0. Calculate the overall output resistance of the amplifier. So, you are asked to find the overall output resistance of the amplifier. The examiner is saying that there is a resistance R0 here. So, you can replace the MOSFET by the small signal model and do it, right. So, let us do it. The small signal model is a basic Norton equivalent. You have GM VGS in parallel with R0. So, this is gate, source and drain. And you can see from the source to ground, there is an RS resistance. And let us apply a test voltage here, V, and find current I. So, output resistance is V by I. Output resistance is V by I. So, now in order to find the ratio V by I, so this current I, which is the entering current, is the same as leaving here, leaving, since no current flows through gate terminal, no current flows through gate terminal. So, let us finish this. According to Kirchhoff's voltage law, VGS plus I into RS is 0. So, your VGS is minus I into RS, minus I into RS. So, now let us apply a KVL here, or for simplicity, if this is source, this node is also source, this node. So, if you do not want a resistor here, you can as well draw it here also. You can as well draw it here, just for your simplicity, right. Otherwise, you can put a resistor here. You have to apply KVL like this. The same node is this. So, I just connected the same resistor here. Just think this is the image of this, right. So, here if you apply KVL, you can finish the problem. So, let us apply KVL. Minus V plus I minus GM VGS into R0 plus I into RS is 0. So, minus V plus I into R0 minus GM R0 into VGS. VGS is minus IRS plus IRS equal to 0. So, what is V by I? V by I. So, you can take I common here. I common, it is going to be R0 plus 1 plus GM R0 into RS. So, this is the output resistance, RS plus GM R0. So, option D, it is R0 plus RS plus GM R0 into RS. This is the output resistance. Now, you can extend this idea to any number of MOSFETs. For example, of course, the solution is done here, but instead of RS, if the examiner gives an additional MOSFET here, additional MOSFET, so this becomes the cascode amplifier. Then you can have an R0 here, R01, and this one you can take it as R02 and do it. So now what will be the problem? It is R0 equal to R01 plus 1 plus GM1 R01 into this RS. What is the value of RS? It is R02. Like this you can do it. So now you can extend any number of MOSFETs. So this whole output resistance is the output resistance of the overall cascade amplifier, and this RS is replaced with R02, right? So like this, and this is approximately, this factor is larger. So GM1 R01 R02, like this also you can do approximately. So this is the solution. So simple, calculating output resistance by Ohm's law is V by I. V by I, apply a test voltage, find the current drawn. Now go through the problem. An op amp has an open loop gain of 7. Its differential input resistance is 10K. And the output resistance of 0 ohms is given. Calculate the closed loop input resistance. Calculate the closed loop input resistance. You can solve this problem by replacing op amp with an equivalent model, or you can do this by simple Miller's theorem also. Miller's theorem, because Miller's theorem states that if you have an amplifier with an input node V2 and output node V0, and V0 is A times of V1 minus V2, and how much is A? A is 7, V2 is V2. So V0 by V2 is going to be minus 7. V0 by V2 is going to be minus 7. So now what happens if a resistance is put between input and output? Now this resistor can be split into two resistances. So two resistances. One is called R1 and the other one is R2. R2 is not needed because we are finding at the input side. So R1 is going to be R divided by 1 minus output voltage by input voltage. The output leg voltage by the input leg voltage where the resistance is connected. So this is 10K by 1 plus 7. It is 10K by 8. It is 10K by 8. So that is the resistance R1. Now let us replace the op amp now with this equivalent. The 10K is split into R1 and R2. And mind you, there is also a differential input resistance of 10K, which you should not forget. So let me draw now. There is 10K and there is an R1. And now this op amp also has some input resistance of 10K. And R2 is not needed. So what is the input resistance? The input resistance is the parallel combination of these two in combination with, in series with 10K. So Rn is going to be 10K plus R1 parallel with 10K. This is the solution. It is 10K plus 10K by 8 parallel with 10K. 10K parallel with by 8 parallel with 10K is 10K by 9. So R parallel R is R by 2. R by 2 parallel with R, R by 3. R by 3 parallel with R, R by 4. So 10K by 8 parallel with 10K is 10K by 9. So it is going to be so it is 10 kilo ohm plus 1.1 K. So it is going to be 11.1 K. Approximately, let's see the options. Yeah, 11.1, option B. And don't forget that there is a differential input resistance here also, right? Or if you don't want to do this method, you can replace op amp with the equivalent like this, and V naught is output resistance is 0, it is AVD. So V naught A is 7 VD. So if you don't want to do by that method, you can apply a test voltage V here, find current I. Just like how we have done for that MOSFET problem, you can do V by I, you will still get the same answer, 11.1 K. 11.1 K, the node voltage here is minus VD and V naught is 7 VD. So you can take some current I1, I2, I3, apply Kirchhoff's laws and do it. Like that also you can do. Go through the problem. Assume the given op amp are ideal. Calculate the output voltage. Calculate the output voltage. So this is a simple problem where you can apply virtual short and solve. Try to apply virtual short for this problem and solve. Okay. So what is virtual short? The voltage at non-inverting and the voltage at inverting both are same. Both are same. So if this is Vx, or you can take this node as Vx. If this is Vy, this node is also Vy. This node is also Vy. And if this node is -1, this is also -1. Since op amp draws no current, you can apply something called the voltage division. Voltage division. So what is Vy? Vy equal to V naught into 1K by 3K plus 1K. It is V naught by 4. It is going to be V naught by 4. Or you can take entering current and leaving current. Entering equal to leaving. You can apply the KCL at this node. If you apply KCL at this node, you will get the same thing, right? Or you can apply voltage division. Now, what is Vx by superposition theorem? What is Vx by superposition? Vx by superposition. You have Vy here, you have Vx, and there is 2K and 1K and 1 volt. So again, if you want, you can apply Vy here and the nodal analysis you can do, or directly superposition theorem. Vx is going to be, this is a non-inverting amplifier for Vy, 1 plus 2K by 1K into Vy, plus for 1 volt, this is an inverting amplifier, minus 2K by 1K into 1. So this is 3 times of Vy. How much is Vy? V naught by 4 and minus 2 is going to be Vx. So Vx is 3 V naught by 4 minus 2 for this op amp. For this op amp, again you can apply the same superposition theorem. And what is V naught due to minus 1? V naught is 1 plus 8K by 4K into minus 1 plus due to Vx minus 8K by 4K into Vx. So what is V naught? V naught is going to be 3 into minus 1, minus 3 minus 2Vx. So, we have to find V naught. Let us eliminate Vx. Let us eliminate Vx. So, what is Vx here? 2Vx equal to minus 3 minus V naught. So, Vx is minus 3 minus V naught by 2. So, let us equate these two and you will get the answer. So, let us equate these two, you will get the answer. So, try to equate them. 3 V naught by 4 minus 2 equal to minus 3 minus V naught by 2. So, this is going to be 3 by 4 is 0.75, 0.75 into 2, 1.5 V naught minus 4 equal to minus 3 minus V naught. So, 2.5 V naught equal to 1. V naught is 1 by 2.5, which is 0.4 volt. But is there a point? Yeah. So, your V naught is 0.4 volt. So, let me repeat this. I applied voltage division here for V naught, which is 1/4 of V naught, because 3/4 is dropped here, 1/4 is dropped here. Your Vy is 1/4 of V naught, and you can apply the same V naught by 4 here and minus 1 here. And here I applied superposition theorem, or you can apply KCL. In the solution I have given with KCL. Here I am doing by superposition, just for a change. This Vy is 1 plus Rf by R1 times of Vx is 1 plus Rf by R1 times of Vy, and due to this it is minus Rf by R1 times of that. Similarly, here also the same superposition theorem I applied. I got Vx. I try to equate them for this solution. So, this is for op amp, first op amp 1, and this is for op amp 2. Okay. Go through the problem. Find Vc max in steady state if the capacitor has an initial charge of 0 volt and a threshold of 1 volt and a threshold of 1 volt. So, before we solve this problem, the basic logic is for an NMOS to be on, remember the source voltage should be lesser than the gate voltage. The source voltage is lesser than the gate voltage at least by Vt, right? It should be less. And the drain voltage, this source voltage cannot be greater than the drain voltage, because the drain voltage happens to be the supply voltage. This source voltage is always less than or equal to the drain. But there is at least a difference of 1 volt here for the MOSFET to go to on state, right? The maximum voltage the source can get is the drain voltage. So, this is a simple logic here. The first MOSFET you can see has a drain voltage of 9 volt, but the gate is 10. The gate is 10. So, you cannot get any voltage here more than 9, and the difference is at least 1 volt has to be maintained. This is the first MOSFET. The second one has a drain voltage of 6 volts. 6 volts. So, the source voltage cannot be more than the drain. The source voltage cannot be more than the drain, and this is again given to the third one. The third one, drain is 10, and here we are connecting a capacitor. So, what is the maximum voltage this capacitor can charge before it makes the MOSFETs to go to off state? So, this is 6. So, this voltage could be maximum 6. It cannot be more than that, right? And now 10 minus 6, you have 4 volt. So definitely these two MOSFETs are on. But if you take 9 here and make this 8, which doesn't make any sense, any physical sense. You cannot have 8 volt when the drain itself is 6. So when this is 6 volt, the maximum voltage you can get here is 6. And 6 minus 1, at least 1 volt difference should be there, is 5. So this capacitor can charge to a maximum voltage of 5. What happens if it charges to 5.00000001? If it charges to 5.000001, then the difference is going to be 0.999999 and the MOSFET will go to off state. So before it makes the MOSFET to go to off state, this capacitor is charged slowly starting from 0. First it is charged to 0, all the MOSFETs are on, then it is charged to 1, all the MOSFETs are on, it is charged to 2, all the MOSFETs are on. Once it charges to 5, all the MOSFETs are just on. If it charges slightly more than 5, then the MOSFET will go to off state. So the maximum it can attain is only 5 volt in this problem.
Okay, pre-gate instrumentation. One more question. The current flowing through a wire of length 2.5 meters is 100 amperes. If the wire is bent into a square, the magnetizing force at the center of the square is fine. See here, now there is a wire, it is bent into the square. It is asking what is the magnetic field at the center. So what is the each side? The total length is 2.5. The each side is 2.5. 2.5 by 4. So how much? And is asking what is the magnetic field at the center. So how much current is flowing? It is 100 amperes. There is a shortcut to find out the magnetic field at the center. So of some n equal sided polygon, H is equal to Ni by pi d tan 180 by n sin 180 by n. Correct? So what is this n? N is the number of sides. For the square, number of sides are 4. So here it is 4 into how much is the current flowing? It is 100 divided by pi into what is the each side? It is 2.5 divided by 4 into tan 45 degrees, which is 1, fine. Sin 45 is 1 by root 2. Now check out this value here. It is 16 into 100 divided by 2.5 into pi into 1 by root 2. So what is this H value? You can check it out. It is approximately 144 point something, but can you approximate it to ampere turn per meter or simply ampere per meter? Fine. So what is the answer for this? Option C is the answer. Okay, pre-gate instrumentation 2 marks question. A ball of radius r has a charge density rho given by rho is equal to rho naught into 1 minus r small r by capital R, where small r is ranging from 0 to capital R. The electric field outside the ball at r distance from the center of the sphere is. So let me draw some diagram here. There is a sphere here whose radius is ranging from 0 to r. So it's asking how much is the electric field on the surface here. You can make use of what is called a Gauss law, which is closed surface integral of E dot dA, which is equal to charge enclosed by epsilon naught. What kind of charge is enclosed? It is a volume charge. Fine. So it is volume charge integral of rho v into dv. Now I will consider the Gaussian surface here itself. Okay, electric field is coming outside like this, and normal direction is also same. This is the electric field direction and normal direction, both are same. Fine. And so this dot product will become simple product. Fine, because electric field direction and normal directions are same. So it is ER into dA, which is equal to volume integral of rho v. It is rho naught into 1 minus small r by capital R, which is r square sin theta dr d theta d phi. Clear? Now you can bring this ER outside, then it will become surface area. So it is rho naught into r square minus r to the power of 3 divided by r into
dr sin theta d theta into d phi. Clear, guys? Perform the integration here. What is this one? It is a surface area. So ER into surface area. What is the surface area of this? It is 4 pi capital R square, which is equal to, it is rho naught into r to the power of 3 divided by 3. It is r to the power of 4 divided by 4 into capital R, where r is ranging from 0 to capital R, into minus cos theta. For the sphere, theta is ranging from 0 to phi, and this is phi. Phi is ranging from 0 to 2 pi. For the sphere, substitute upper limit minus lower limit. So the ER is equal to 4 pi into capital R square, which is equal to, this one is upper limit minus lower limit. So it is R cube by 3 minus capital R to the power of 4 divided by 4R into minus 1 minus into 2 pi. So the ER is equal to 4 pi capital R square V rho naught. So this will become, you can check it out, it is R to the power of 4 by 12 into 4 pi. Cancel out the 4 pi on both sides. So it is ER is equal to rho naught into R to the power of 2 divided by 12. Don't forget epsilon naught, divided by epsilon naught. 1 by epsilon naught. Here also 1 by divided by epsilon naught. Go back, rho naught. Here, yes. So this is R cube, not R to the power of 4, it is R cube. So this is just will become R. So rewrite this one, it is rho naught into R divided by 12 epsilon naught. Go back, option D is answer. Option D is answer.
Hello everybody, welcome back. So now we'll start the discussion on the gate questions of pre-gate examinations for power system subject. Right students? So we'll see the first question. So this is the first question. A 3-phase 100 MVA 33 kilovolts transmission line is having a per phase resistance of 10 ohms. The per phase impedance of transmission line to allow the maximum power through it will be. So what is the impedance, per phase impedance to allow maximum power through it? See, to allow the maximum power through the transmission line, the relation between the resistance and the reactance will be, right? What is the relation between resistance and reactance? XL is equivalent to root 3 times of R. XL is equivalent to root 3 times of R. Therefore, when you substitute this, XL is equivalent to root 3 times of R and resistance is given 10 ohms. Therefore, XL is equivalent to 10 root 3 ohms. Therefore, what is the value of impedance? Z is equivalent to magnitude of Z at an angle of theta, right? So what is magnitude of Z? The magnitude of Z value is under root of R square plus XL square. It will be under root of R is 10 square plus 10 root 3 whole square. So it will be 40 ohms. And whereas theta is equivalent to tan inverse of XL by R. XL by R. It will be tan inverse of 10 root 3 divided by 10. Tan inverse of root 3, it will be 60 degrees. Right? So that it will be 40 at an angle of 60 degrees. 40 at an angle of 60 degrees is the answer. Alright students, very simple question. So now we'll go for the next question here. So this is the next question. Consider the power system network shown below. The network consisting of various directional and non-directional relays, overcurrent relays, then the backup relays for relay 2. So what are the backup relays for relay 2? So we know that the backup relays must be non-directional relays only. So if you take relay 2 as a directional relay, relay 4 is also a directional relay, relay 5 is also a directional relay. So for R2, the relays which are carrying current along with R2, they are the backup relays. right? We can say that for relay 2, the backup relays, for relay 2, which are the backup relays for relay 2? R3 and R6. R3 and R6 will become the backup relays. And for relay 4, R1 and R6 will become the backup relays. R1 and R6 will become the backup relays. And for relay 5, so R1 and R3 will become the backup relays. R1 and R3 will become the backup relays. R7 and R8, even though they are not directional relays, right? Even though they are a non-directional relays, we cannot say, so even though they are non-directional relays, we cannot say that, so R7 and R8 are the backup relays. Why? Because they cannot carry current in the reverse direction here, right? So to give the backup, so nobody is there to supply the current in the in this direction, right, students? But for a relay 1, relay 3 and relay 6, generators 1 and 2 will supply the currents. Alright, students. Now we'll see the next question here. So for this question, the perfect answer is for relay 2, R3 and R6. R3 and R6. The next question, for the power stem network shown below, the voltage at both ends of the transmission line are maintained at 1 per unit. If the capacitor connected at the receiving end of the transmission line supplies a reactive power of 1.2 per unit and load absorbs an active power of 1 per unit, which of the following is are correct? Right. So here at sending end voltage is 1 per unit, receiving end voltage is also 1 per unit, line reactance is 0.5 per unit, right? Then what is the reactive power flow in the transmission line? So what is this reactive power they are asking? See, we know the power transfer equations. According to the power transfer equations, so if you calculate the active power and reactive power at this point, see, at this point I am calculating SR, where SR is equivalent to PR plus J times of QR, where PR is equivalent to PD and QR is equivalent to, what is QR is equivalent to? It's not only QD, QC is supplying, so it will be QD minus QC. QD minus QC. Out of this, they are saying that QC is given, 1.2 per unit is the QC value they have given. Now, PD value given, it is 1 per unit. 1 per unit. Now, they are asking what is the value of QR value. We are having the power transfer equation, PR is equivalent to VS VR divided by XL into sine of delta 1 minus delta 2. Where delta 1 is delta, delta 2 is 0. Substitute those values. VS is 1 per unit, VR is also 1 per unit, XL is 0.5, PR is 1 sine delta. If you calculate this one, delta you will get it as 30 degrees. The value of delta is 30 degrees. Once you got the value of delta, you can substitute this delta in the QR equation, where QR is nothing but VS VR divided by XL into cos of delta 1 minus delta 2 is delta minus VR square divided by XL. Substitute the values here. It is 1 into 1 divided by 0.5 cos 30 minus 1 square divided by 0.5. If you calculate this, we will get minus 0.267. Minus 0.267 per unit is the answer, right? So that the reactive power flow in the line is minus 0.267 per unit. And suppose if they are asking, for what is the reactive power demand? What is the reactive power demand? The reactive power demand QD is equivalent to, the reactive power demand QD is equivalent to, see, you have written the equation here, QR plus QC. QR plus QC, where QR is nothing but minus 0.267 and QC is nothing but 1.2. So it will be 0.933 per unit. right? That is the reactive power demand. So that this statement is also correct. Statement 1 and statement 4, both the statements are correct here. Right, students? So now we'll go for the next question here. The stator winding of an alternator should be protected by merge price protection scheme if the pickup current of the relay is 0.3. So pickup current is given 0.3 amperes. Then, so when I0 is 0.2, relay not operates. When I0 is 0.3125, the relay I0 is equivalent to 0.3125 and the relay not operates. I0 is 0.3125 and the relay operates like that. They have given the options. So means we need to calculate I0 first of all. To calculate this I0, so the I0 value is equivalent to magnitude of I1 minus I2, where I1 is the current flowing here, I2 is the current flowing here. They are the two currents. The difference between those two as a magnitude we are calculating, so which is flowing through the relay operating coil, ROC. So to calculate I1, so which will be 125 divided by CT1 ratio. CT1 ratio. It is 125 divided by, what is CT1 ratio? 400 divided by 5. Right? And what is the value of I2? The value of I2 is nothing but 150 divided by CT2 ratio. So it is 150 divided by 400 divided by 5. 400 divided by 5. Right? So it will be 125 into 5 divided by 400. It is 150 into 5 divided by 400. Then if you calculate this I0 value, which is magnitude of I1 minus I2. So what is that magnitude? It will be 125 into 5 divided by 400 minus 150 into 5 divided by 400. So this value will be approximately 0.3125 and the relay operates. 0.3125. Why the relay operates? The pickup current is only 0.3. If current is more than that of the pickup current, the relay is going to be operated. And relay operates. Relay operates. So that the correct answer is option C here. Right? Right, students. The next question is, the bus admittance matrix is used to conduct the load flow study. A 3-bus power system network is given here. This is the 3-bus network given. And the per unit reactances of lines, series and shunt elements are specified. So all are given are per unit reactances. The generator reactance are also specified. The tap ratios of transformers 1 and 2 are, so transformer 1 is 1.05 and transformer 2 is 1.1. The self admittance of bus 1 and bus 3 are respectively. Right? So we are having tap changing transformers. Along with the tap changing transformers, they are asking the self admittance of bus 1 and bus 3. So first of all, we will convert all these into primitive admittance form. So first of all, what is Y12? What is Y12? So Y12 is minus J10 and Y12 dash. What is Y12 dash? It is J0.1. Y10. What is Y10? Minus J4. And so what is this Y20? First of all, we'll write it along with 1. Y13. What is Y13? It is minus J20. And this one Y20. Y20. It is minus J2.5. And Y23. Y23. It is J0.5. J5. Minus J5. Minus J5. minus J5, and Y23 dash, it is J0.05, J0.05. These are the values, right? So let me confirm the values once, right? So we are having Y10 J4 and Y20 J2.5, right? Remaining values are almost perfect, right? Right, students, right? So these are the values we are having. They are asking what is Y11, right? So to calculate this Y11 value, Y11 is equivalent to Y10 plus Y12 plus Y12 dash by 2 into T1 square. That is the tap ratio of transformer T1 plus Y13 into T2 square. That is the tap ratio of transformer T2. Why? Because it is in this line. It is in this line. Between 1 and 3, we are having the transformer T2. Between 1 and 2, we are having transformer T1. Right? So substitute the values. What is Y10? So the value of Y10, it is minus J10 plus Y12. What is Y12? Y10 is minus J4. Y10 is minus J4. It is minus J4. So Y12 is minus J10 plus Y12 dash by 2. So it is minus J0.1 by 2. It is J0.05 into tap ratio of transformer T1. What is the tap ratio of transformer T1? 1.05 square. 1.05 square plus Y13. So what is Y13? Y13 minus J20 into tap ratio of transformer T2. It is 1.1 square. Right? So if you calculate this, approximately you will get minus J39.17. That is the value of Y11. And if you calculate Y33, so Y33 value. So for Y33, so this value, and this half of this value. So this is Y13. It is minus J20 plus Y23 minus J5 plus half of this value. So this is 0.05 by 2 plus J0.05 by. So if you calculate this value, we'll get J minus J24.975. Right? So that the perfect answer is option D. So option D is the perfect answer, right? So along with that, tap changing transformers, right, students? So now we'll go for the next question here. A three-phase synchronous generator rated as 100 MVA, 11 kilovolts and 50 Hz. The sequence impedance are Z1, Z2 is equivalent to 0.15 per unit, Z0 is 0.05 per unit. Generator neutral is grounded by an impedance of 0.05 per unit. Neutral impedance is also given. A line to ground fault, LLG fault takes place with a fault impedance also given 0.05 per unit. The zero sequence impedance network terminal voltage during the fault in kilovolts, right? Right. So they are asking what is the voltage across the neutral zero sequence network terminal voltage. Zero sequence network terminal voltage, not the neutral voltage. Zero sequence network terminal voltage. See, whenever you are having the LLG fault, we can take the positive sequence current IA1 is equivalent to EA1 divided by Z1 plus Z2 plus Z0 plus Z1 plus Z2 parallel to Z0 plus 3Zn plus 3Zf. So this is the formula we are having, right? we can substitute the values here. We can substitute the values. So it will be EA1. What is the value of EA1? We can take it as 1 per unit. 1 per unit divided by Z1. 0.15 plus 0.15, which is parallel to Z0 0.05 plus 3Zn, 3 times of 0.05, 0.15 plus 3 times of Z of 0.15. Calculate this value, you will get the value of IA1. So if you see the value of IA1, you are going to get it as 3.92 per unit. 3.92 per unit. That is the value of IA1. And if you see the sequence network for this fault, this is the positive sequence network, and here we are having the negative sequence network, and the zero sequence network will be, so this is the zero sequence network along with the neutral impedance, and here we have to take the fault impedance ZF. So this is 3 times of ZF here, and this is Z0, this will be 3 times of Zn. 3 times of Zn. So this is the zero sequence network, positive sequence network and negative sequence network. So this will be Z1, Z2. Here the current is IA1. Here the current is IA0. Right? Not in this direction, in the reverse direction. IA0 will be in the reverse direction. Then what is the value of IA0, students? IA0 is equivalent to total current is IA. Actually, it is minus. We are calculating the magnitude, right? It will be IA1 into impedance of opposite branch Z2 divided by total impedance. What is that? Z2 plus Z0 plus 3Zn plus 3Zf. Substitute the values. What is IA1 you got? 3.92 into Z2 is 0.15 divided by Z2 0.15 plus Z0 0.05 plus 0.15 plus 0.15. Calculate these values, you will get the value of IA0. The value of IA0, you will get it is 1.176 per unit. 1.176 per unit. That is the value of IA0. So once you got the value of IA0, you can calculate what is this voltage. What is this voltage? VA0. That is the zero sequence terminal voltage. Therefore, the value of VA0 is equivalent to 1.176 into Z0 plus 3Zn. It will be 1.176 into, what is the value of Z0, students? 0.05 plus 0.15. Right? So if you calculate that value, you are going to get, right. So once you got the value of IA0, you can calculate the value of VA0. So VA0 means this total will be the zero sequence network now. So from here to here you can calculate what is that? VA0. So the value of VA0 is equivalent to IA0 into, what are the values? Z0 plus 3Zn plus 3Zf. Z0 plus 3Zn plus 3Zf. Or otherwise you can calculate IA2 into Z2 also is the answer. IA2 into Z. What is the value of IA2? You can calculate IA2, which is impedance of opposite branch divided by total impedance. Like that also you can calculate. Anyway, so you are strong in networks, right? Right. So this will be 1.176 into 0.05 plus 0.15 plus 0.15. So it will be 0.4116 per unit. 4116 per unit. And they are asking the value of VA0 in kilovolts. Therefore, VA0 actual value is equivalent to VA0 per unit value into VB phase value. It is 0.4166 into what is the voltage they have given? 11 kilovolts. It is 11 divided by root 3 kilovolts, right? So if you calculate, approximately we are going to get 2.61 kilovolts. 2.61 kilovolts is the answer, right, students? So these are the questions we are having in the power systems, right?
Next question. In the following chopper, the duty ratio of switch S is 0.4, that is D given. The inductor and capacitor are sufficiently large to ensure continuous inductor current and ripple free capacitor voltage. The magnitude of average voltage across diode is, so they are asking what is the VD average magnitude. So let me take the voltage across diode is a VD, anode positive, cathode negative, and suppose this voltage is a V0. Be careful for buck boost, this is a buck boost converter. For buck boost converter, your output voltage polarity plus minus, right? Yeah, it is given that D equal to 0.4, right? And our task is to find VD average. VD average, all right? Now here, so this is a buck boost converter, continuous conduction they are saying. What is the output voltage expression? We know V0 is a D upon 1 minus D into Vs. Vs is 20 volt, duty cycle is 0.4. So I can find here first V0. Given converter is a buck boost converter. Buck boost converter. V0 equal to D upon 1 minus D into Vs. So it is 0.4 upon 1 minus 0.4 into Vs is a 20, right? So it is a 0.4 upon 0.6 into 20. So it is 13.33 volt. This is V0. So V0 is 13.33 volt. Now let us find the VD value during on time of a switch and during off time of a switch. In this circuit, during 0 to T on or 0 to DT, capital DT, switch is in on state, diode will be in off state na. At that time, what is VD? VD will be equal to anode side voltage, which is a minus V0, minus cathode side voltage. Cathode side voltage is plus 20. So my VD will be minus V0 minus 20 during on time. And during off time of switch, when switch off, at that time diode conduct because of this inductor. So when diode conduct, what is VD? 0. So here I am writing during T equal to 0 to dt, during T equal to 0 to dt, switch on, switch S is in a on state, diode off state. What is VD? It is a minus V0 minus Vs, that is equal to minus 13.33, and minus Vs, Vs is a 20 volt. So it is equal to minus 33.33 volt. This is our VD, alright, during on time of a switch. And what is the VD during off time of a switch? During dt to capital T, during T equal to dt to capital T, yes, switch off, and because of inductor, diode will start conduction. So my VD equal to 0. VD is a 0, right? So if I draw the plot for voltage across diode VD, it is like this. Yes, this is minus 33.33 volt, right? Now here we can write VD average, area upon periodicity. minus 33.33 into dt upon t. So it is minus 33.33 into t cancel out. Duty cycle is 0.4, right? So if you take this multiplication, you will get it as a minus 13.33 volt. So what is the magnitude? Magnitude of VD average is 13.33. Magnitude is positive 13.33 volt, right? So answer is 13.33 volt. Yeah, next question. Let us now discuss the 2 marks questions. Yeah. The IGBT used in a circuit has following data. On time is 2 microsecond, off time is 1.4 microsecond. Duty cycle 0.6, VC is set, means when IGBT is in a saturation mode, then it is causing a voltage drop of 2 volt and switching frequency 1 kilohertz. Peak instantaneous power loss in IGBT during turn on and turn off respectively is. They are asking peak instantaneous power loss, peak value of instantaneous power loss. Okay, and assume linear variation in VC and IC during T on and T off, and they have given the 4 options. Okay, and this is the circuitry they have given. IGBT, load resistor and supply voltage is 200 volt. Okay, 200 volt. Now here let me consider this voltage is a VCE, right, and current here is a IC. So first let us find, when IGBT is in a conduction mode, what is the value of current flowing through the IGBT and what is the value of voltage across the IGBT. And similarly, when IGBT is in an off state, what is the VC and IC, let us find. Okay, right. So here during on state, during on state of IGBT, means IGBT is acting as in a on state. Tell me, if IGBT is in on state, the operating point will be in which mode, in which region? Saturation region. Yes or no, right? So when IGBT is in a saturation region, then they have given the voltage drop across IGBT, that is VC is set, that is equal to 2 volt. So here voltage across IGBT, VCE is equal to VC set, which is equal to 2 volt, right, which is equal to 2 volt. Next, what is IC now? For finding IC, simply check this loop. If I want to find IC, how I can write? This voltage minus this voltage upon this resistance now, or you can apply KVL also. Plus VCC minus IC into RL minus VCE equal to 0. So from that you can get IC value. Okay, so I can write here IC equal to VCC minus VCE, but when IGBT is in on state, VCE is nothing but VCE saturation upon load resistance RL. So now put here values, it is 200 minus VCE saturation is 2 volt upon RL is 10. So it is equal to 198 by 10. So it is 19.8 ampere. So current flowing through the IGBT when it is in a on state is 19.8 ampere, right? Voltage across IGBT is 2 volt. Next, when IGBT is in a off state, during off state, yes, during off state of IGBT, in the question they have not commented anything about the leakage current of IGBT. So simply neglect the leakage current. So IC equal to 0. IC is 0. If IC is 0, what is VCE? If IC is 0, what is VCE? Here IC is 0 now. Can I say that VC is nothing but simply VCC, that is 200. VCE equal to VCC is equal to 200 volt, right? Is equal to 200. So here IGBT current and voltage during off state and during on state we have written. Now how is the plot for VC and IC with respect to time during turn on and turn off transition? It is given that the linear variation This is T on and this is T off. So now I can write here before T on, this is turn on transition na? So before turn on transition, your IGBT will be in a off state. So when IGBT off, next here it is successful on, and again here it is off. So when IGBT is in a off state, before T on IGBT is in off state. So when IGBT is in off state, what is the value of current? 0. During T on it will increase linearly and it will be now constant to 19.8 given. After that decrease and become 0. This current is 19.8 ampere, right? Next, when IGBT is in a off state, what is the voltage across IGBT? 200 volt. So here it is 200. After that, voltage will decrease. It will reach to on state voltage drop. What is the on state voltage drop? That is VC is at, that is equal to 2 volt. After that, constant, then increase linearly. Yes, 200 volt. This voltage drop is of 2 volt. Yes, I am writing here. This voltage drop is of 2 volt, right? Now, if you draw the plot for power loss in IGBT, yes, power loss in IGBT. So this power loss will be like this. Yes. So here during T on, voltage falling linearly, current increasing linearly. So if you take the product of voltage and current, both are linear but with opposite slope. So you'll be getting bell type of the curve. This is also the bell type of the curve you'll be getting. So peak instantaneous power loss means power loss here and power loss here we need to find. So peak instantaneous power loss is taking place at a midpoint of T on and midpoint of T off. This total is T on. So this point is midpoint of T on and this point is a midpoint of T off. So for finding the peak instantaneous power loss, simply we need to check at this midpoint of T on and midpoint of T off, what is the value of VC and IC. So can I write here at midpoint of T on, yes, peak instantaneous power loss during T on. Peak instantaneous power loss during T on. During T on, yes, is equal to, at the midpoint of T on, your current will be at 50% of 19.8. It is linear, na? So current will be at 50% of 19.8. So I can write 19.8 by 2. And voltage will be at the midpoint of difference between these two. 200 minus 2 upon 2. 200 minus 2 upon 2. So it is equal to 19.8 by 2 into 198 by 2. So you can take the product, you will get it as a 980.1. Yes. And similarly, you can find the peak instantaneous power loss during T off. during T off. Yes, it is again 19.8 by 2 into 200 minus 2 by 2. So it is again 980.1 watt. Okay. So here you need to understand the peak power loss will be taking place only at the midpoint of T on and midpoint of T off. And at midpoint of T on and T off, we need to find the voltage across IGBT, current flow through the IGBT. So correct answer is option C, 980.1 watt, 980.1 watt. All right. Yes. The next question. A 24-volt battery feed a single phase full bridge inverter when output is connected to single phase ideal transformer. Transformer primary has 10 turns, secondary has 100 turns. Transformer secondary is connected to resistive load of 100 ohm. Neglecting harmonics in load voltage, RMS value of the switch current in ampere is. They are asking RMS value of switch current. Yes, it is given that supply voltage, single phase full bridge inverter, supply voltage is a 24 volt Vs, 24 volt. Transformer is having a primary turns equal to 10, secondary turns equal to 100. Next, transformer secondary is connected to the resistive load of 100 ohm. Yes. Neglecting harmonics in load voltage means output voltage having only fundamental component. So V0 equal to simply V01. RMS value of switch current. Let me write it as IS1 RMS. We need to find. All right. So let us first draw the circuit diagram, and from that we can understand. So single phase full bridge inverter means how many switches? 4 switches. Transformer primary and secondary. Secondary side is having a load resistance R. Right? The switches here Vs, S1, D1, S2, D2, S3, D3 and S4, D4. This voltage is V0, right? Or let me write it as V01 because only fundamental na. Yes, V01. So voltage at the primary side of the transformer is V01. Voltage at the secondary side of the transformer, let me write it as V02. Let me write it as V02. Suppose this voltage here is a V02. If this is V02, here it will be V02, right? V02. And load resistance is a R, right? Yeah. Now, if supply voltage is, if output voltage is having only fundamental component, okay. So first thing is, can I find here, suppose this current is IS1, right? IS1. Let me consider this current as I01, right? I01. And this current has a I02. I02, right? So primary side current I01, secondary side current I02. Okay, right. Now here, our task is to find the IS1 RMS. Now here can we find the RMS value of output voltage of inverter, means input voltage to the transformer, that is V01. Okay, only fundamental component is present, they are saying, right? So what is the V01 RMS? V01 RMS, that is RMS value of output voltage of inverter, that is primary side voltage at of a transformer. V01 RMS, it is 2 root 2 into Vs by pi na, we have written na 4 Vs by pi upon root 2, that is 2 root 2 Vs by pi. So it is 2 root 2 into Vs is a 24 upon pi. 2 root 2 upon pi is nothing but 0.9. 0.9 into 24. Roughly you will get it as 21.6 volt. This is V01 RMS. Now can we find V02 RMS? V02 RMS. Yes. For that use the transformation ratio, turns ratio. V02 upon V01 equal to N2 by N1 na. So similarly here V02 RMS upon V01 RMS equal to N2 by N1. Now put the values here. V02 RMS is, we need to find, upon V01 RMS 21.6 is equal to N2 by N1, N2 100, N1 10. So 100 upon 10. Yes, simplify this, you will get V02 RMS. It is 10 into 21.6, that is 216 volt. V02 RMS. That is RMS value of voltage at a transformer secondary side. That is nothing but voltage across load resistor R. Now can we find I02 RMS? I02 RMS is equal to, yes, V02 RMS upon R, which is equal to 216 upon load resistance is 100 ohm upon 100. It is equal to 2.16 ampere. This is I02 RMS. Now let us find I01 RMS at primary side current. I01 RMS. How to find? I01 RMS upon I02 RMS is equal to primary side current upon secondary side current is equal to N2 by N1. So I01 RMS upon I02 RMS is 2.16 is equal to N2 by N1, 100 by 10. So from this I can write I01 RMS is equal to 21.6 ampere. This is RMS value of current flowing through the transformer primary, right? Now how will be my I01 waveform? If my output voltage is having only fundamental, so therefore my I01 will be pure sinusoidal. So I01 will be like this. Pure sinusoidal waveform. Yes, which switches conduct? Yes, 0 to pi. Which switches conduct here? S1, S2. Load is resistive na, so only switches conduct. And here S3, S4. So next to that, how will be my IS1 waveform? IS1 waveform will be only half sinusoidal na? It will be only half sinusoidal waveform. So this is your peak value. Let me write as IM. Right? So half sinusoidal current waveform will be there for switch. So how to find the RMS? IS1 RMS is equal to, for half sinusoidal signal, RMS value is amplitude by 2 na, that is IM by 2. IM is nothing but I01 RMS into root 2 upon 2. So it is equal to I01 RMS 21.6 into root 2 by 2 na. So simplify this, you will get it as 15.28 ampere, right? So IS1 RMS. Next, yeah. Next question. The figure below shows an uncontrolled diode rectifier. Uncontrolled diode rectifier supplied from 220 volt 50 hertz single phase AC source. The load draws a constant current of 5 ampere. Load current is a constant, means load is highly inductive. The conduction angle of diode D1 and freewheeling diode DF are respectively. Here source inductance is also present. So if source inductance is present, how will be your diode D1 current waveform and diode freewheeling diode current waveform? Let us understand, and from that you can find the conduction angles. ID1, IDF, right? So here my ID1 waveform will be like this. Because of source inductance, you will not get a sudden rise or sudden fall in a diode current waveform, because my source inductance will not allow that. Without source inductance, your ID1 will be at 0, it will be sudden rising from 0 to I0, and 0 to pi it will be constant. At pi it will suddenly drop to 0, but source inductance is present. Source inductor will not allow this diode current to rise suddenly or fall suddenly. If this is ID1 waveform, how will be my IDF waveform? IDF. Be careful here. Addition of ID1 and IDF should be equal to I0, right? So for finding the diode, freewheeling diode current waveform, simply subtract ID1 from I0, right? So it is I0 minus ID1. You will be getting this type of waveform. This waveform is for continuous cycle. Right? So what is the conduction angle of diode D1? It is a pi plus mu. And conduction angle of freewheeling diode, this is also pi plus mu. This is pi to 2 pi means pi, and here 0 to mu, that is mu. So conduction angle of diode D1 and freewheeling diode is simply pi plus mu. Now how to find the pi plus mu? For that, here simply during omega t 0 to mu, both diodes are in a conduction mode now. So during omega t 0 to mu, if both diodes are in a conduction mode, means this is also on, this is also on. So across supply voltage 0 to mu, supply voltage positive, means polarity plus here, minus here. So across supply voltage directly LS, and it is a direct short connection. Short circuit na? Yes, so we can draw the equivalent circuit, and from that we can derive one expression. Okay. So during omega t equal to 0 to mu, I can draw the circuit like this. Vs, Ls, and across it a direct short circuit. During 0 to mu, my Vs is positive, and here current is a Is, or I can write it as ID1, right? ID1. Is and ID1 both are same, check. Source current Is and ID1 both are same, na? Right? ID1. So instead of Is, I have written it as ID1. No problem. Now let us apply KVL to loop. Yes, KVL to loop. yes, KVL to loop. So I can write it as plus Vs minus Ls into dId1 by dt equal to 0. So Vs is Vm sin omega t into dt is equal to Ls into dId1, right? Simply I have shifted this term to the right hand side and then dt I have taken at a left hand side. Now integrating both sides. Integrating both the sides. So now I can write it as integration Vm sin omega t dt is equal to integration Ls into di1. Yes, we are talking about which interval? Interval from omega t 0 to mu. So if omega t changing from 0 to mu, how the time will change? Time will change from 0 by omega to mu by omega. So 0 by omega means 0 and mu by omega. So I have taken the limits for the integration. And during this interval 0 to mu, how the ID1 changes? 0 to I0. So limits will be 0 to I0. Right? Now let us simplify this. Vm into integration of sine minus cos of omega t upon omega 0 to mu by omega is equal to Ls into I1 limit 0 to I0. Now put the limits, take that omega outside. So it is Vm by omega into bracket. These limits are only for time t. This is dt na. So these limits are for time t. These limits are not for omega t. These limits are for time t. So I can write it as minus cos mu plus cos 0 minus cos of mu plus cos of 0 is equal to Ls into I0. Ls into I0. Further shift that omega this side, Vm that side, right? And we can write 1 minus cos mu. So 1 minus cos mu is equal to omega Ls into I0 upon Vm. Now put the values here. 1 minus cos mu is equal to omega means 2 pi into 50 supply frequency. Ls is source inductance. It is given that 10 millihenry, right? 10 millihenry into I0. Load current is 5 ampere upon Vm. Supply voltage is 220 volt RMS. So 220 into root 2. Yeah, simplify this, you will get mu. Yes, mu equal to 18.28 degree. So therefore, conduction angle of diode D1 and freewheeling diode. Conduction angle of diode D1 and freewheeling diode is equal to pi plus mu, that is equal to 180 plus 18.28. So it is 198.28 degree, right? So for both the D1 and freewheeling diode, the conduction angle will be 198.28, right? 198.28. So option D is the correct option. All right? Yeah. Yeah, so these are the questions from subject power electronics, right? Hello everyone. Let us now discuss the questions related to the subject power electronics. Okay, pre-gate 2025 ACE Engineering Academy. So let us first discuss the 1 mark questions. Yeah, a 3-phase full converter fed from star connected 3-phase 400 volt 50 hertz supply is feeding a RLE load with R is a 2 ohm, EMF E is a 100 volt. An inductor is large enough to make load current constant and ripple free. Means load is a highly inductive. RLE load, constant load current. Which of the following statements or statement regarding supply phase current and thyristor current is or are correct? Okay, so they are saying regarding the supply phase current. Statements regarding the supply phase current means IA and thyristor current, that is IT, is or are true. This is a multiple select question. Okay, yeah. First option is the first two frequency components present in a supply phase current are 50 Hz and 150 Hz. So if you check the supply phase current, how is the supply phase current waveform for 3-phase full converter feeding to highly inductive load? Yes, my supply phase current waveform is a Cauchy square function having a pulse width of 120 degree. Check this, we already discussed during our classroom sessions. Pi by 3 plus alpha to pi plus alpha, 4 pi by 3 plus alpha till 2 pi plus alpha, and here it is alpha. Right, the waveform is like this. Minus I0 and plus I0, right? This is supply phase current waveform. In this waveform, which harmonics are absent? All even and triple N harmonics. In IA, that is supply phase current, all even and triple N harmonics are absent. So if all even and triple N harmonics are absent, means which frequency components will be present? N equal to 1, N equal to 5, 7, 11 and so on. Except even and triple N, whatever the harmonics are present, those components will be present here. So here the first statement is the first two frequency components. First two frequency components they are saying. Here they are not asking the first two harmonic frequency components. Be careful. Here harmonic word is not present. So first two frequency components means frequency corresponding to N equal to 1 and N equal to 5. What is the frequency of N equal to 1? That is fundamental. It is a 50 Hz, same as that of the supply. And frequency of 50 is 5 into 50 means 250 Hz. So first two frequency components is 50 Hz and 250 Hz, and they have given, yes, 50 Hz and 250 Hz, means statement A is a correct statement. Next, RMS value of supply phase current is I0 by root 3. Check here, what is IA RMS here? IA RMS, yes, it is amplitude square function duration upon periodicity na, to the power 1 by 2. So I0 square into function duration, that is 4 pi by 3 upon 2 pi. To the power 1 by 2. So it is equal to under root 2 by 3 into I0 na, under root 2 by 3 into I0. Next, so here the statement given is RMS value is root 2 by 3 into I0, and what they have given? RMS value of supply phase current is I0 by root 3. So this statement is not correct. All right. Yeah, third is RMS value of SCR current is I0 by root 6. Let us check now SCR current waveform. How will be your SCR current waveform? Check the IT1 waveform, thyristor T1 current waveform. Yes, we know during this interval thyristor T1 conduct na, and during this T4 conduct. So thyristor T1 current waveform is only from pi by 3 plus alpha to pi plus alpha. It is I0. So my IT waveform is like this. So my IT waveform is like this. Yes, I am drawing here. Pi by 3 plus alpha till pi plus alpha out of 2 pi. Yes. This is IT waveform, which is a pulsating, na? So what is IT RMS? IT RMS will be equal to I0 by root 3, right? And in the statement they have given it as I0 by root 6, na? So this is not correct. All right. Next, ratio of RMS supply phase current to RMS SCR current is root 2. So RMS supply phase current means IA RMS to IT RMS ratio. What is IA RMS upon IT RMS? IA RMS is root 2 by 3 into I0. And IT RMS is I0 by root 3. Right? So if I simplify this, I will get it as only root 2. Right? Only root 2. So again, if you check the ratio, the statement D is a correct statement. So here, statement A and D, these are the correct statements. So answer will be A and D. This is a multiple select question, right? Multiple select question. Yeah, next question. A single phase voltage source inverter supplies a purely inductive load. On Fourier analysis, the output current waveform is found to have an nth order harmonic of amplitude sigma n times that of the fundamental frequency amplitude. Okay. The ratio of output voltage at fundamental frequency to nth harmonic frequency output voltage is. So here it is given that load is a purely inductive, supplying a purely inductive load. Purely inductive load. And it is given that on Fourier analysis, the output current waveform is found to have nth order harmonic of amplitude, means I0n peak. It is given that I0n peak is equal to sigma n times I01 peak, right? Nth order harmonic current amplitude is a sigma n times the fundamental current amplitude, right? And they are asking the ratio of output voltage at fundamental frequency amplitude, that is V01 peak upon V0n peak. V01 peak to V0n peak they are asking ratio. So now here I am writing this I0n peak is equal to sigma n into I01 peak. So I0n peak is equal to sigma n times I01 peak. Sigma n times I01 peak, right? Now further can I write it as I0n peak is nothing but V0n peak upon Zn, which is equal to sigma n times I01 peak is V01 peak upon Z1, right? So therefore here V0n peak upon what is the Zn? Nth order harmonic impedance, load is purely inductive, so it is n omega L is equal to sigma n into V01 peak upon Z1. Na? Z1 is omega L, right? So here this will get cancelled out. So can I write V01 peak upon V0n peak? V01 peak upon V0n peak is equal to 1 upon n into sigma n, right? So final answer will be 1 upon n into sigma n, right? Yeah. So if you check here, option 1 upon n sigma n, option B is the correct option. All right. Yeah. Next question. In the following chopper, the duty ratio of switch ES is 0.4. Duty cycle given D, capital D. The inductor and capacitor are sufficiently large to ensure continuous inductor current and ripple free capacitor voltage, means conduction is a continuous. The magnitude of average voltage across diode is, yeah, they are asking what is the VD average, right? What is the VD average? Magnitude of. So this voltage, let me write it as VD, voltage across diode. So can I here VD average magnitude they are asking, magnitude they are asking. Consider this voltage as V0, right? V0. Now this is a buck boost converter na, buck boost converter. We know in buck boost converter for continuous conduction output voltage is D upon 1 minus D into Vs na. Vs is a 20 volt, duty cycle given 0.4. So first find the V0. Okay, first find V0. So here I can write buck boost converter. Given circuit is a buck boost converter. So here V0 equal to D upon 1 minus D into Vs. So it is 0.4 upon 1 minus 0.4 into Vs is a 20 volt, right? So it is like 0.4 by 0.6, that is 4 by 6 into 20. So it is 13.33 volt. This is a V0. But our task is not to find V0. Our task is to find the VD average, average voltage across the diode. Yeah, now here tell me, during t equal to 0 to t on, what will happen in circuit? Switch will be in on state, diode will be in off state na. Your inductor will store energy, capacitor will be like a discharging. Okay, at that time what is the VD, that we need to find first. Okay, and when switch is in a off state, at that time diode will be in a conduction mode. At that time what is the VD, that we need to find. Okay, so here check, during t equal to 0 to t on, during t equal to 0 to t on, or you can write a dt. T1 is nothing but dt. Yes, switch on, diode will be in a off state. So when switch is in a on state, diode is in a off state, what is the VD? Switch on means this is acting as a short circuit, and this is open circuit now, diode. So what is the VD? VD means anode side voltage minus cathode side voltage. Check what is the anode side voltage? Anode side voltage is V0. What is the cathode side voltage? Cathode side voltage is 20, right? Or you can apply KVL also. So it is plus 20 plus VD minus V0 equal to 0, right? Plus 20 plus VD minus V0 equal to 0. So what is VD? VD equal to plus 20 minus V0, plus 20 minus V0, all right? So here, now here, one more thing. Actual polarity of V0, we consider it as plus here minus here. Be careful, right?
Clear, guys?
Hi, myself P. Venkatrao. Now pre-gate maths questions I'll discuss for both electronics and communication engineering and electrical engineering. Question number 1 from calculus. Just observe this, the area of the region bounded by the parabola y minus 2 whole square equal to x minus 1, the tangent to the parabola at the point 2, 3 and x-axis, means we have to sketch the area occupying or bounded by y minus 2 whole square equal to x minus 1, and we have to draw a tangent to the parabola at the point 2, 3 that will touch x-axis at some point, and sketch the area bounded by x-axis and the parabola and the straight line. So first of all, rough diagram, let me draw rough diagram. Do you know this is y square equal to x parabola? This is y square equal to x parabola. If x is replaced by x minus 1, same parabola shifted 1 unit right. So observe this, y square equal to x minus 1. Y square equal to x minus 1 means same y square parabola is shifted just 1 unit right from its original position. This is y square equal to x minus 1 parabola. Because if x is replaced by x minus 1, the original parabola shifted 1 unit right from its original position. Similarly, if y is replaced by y minus 2, then its original parabola will be shifted up 2 units from its original position. If y replaced by y minus 2. If y replaced by y minus 2, the same parabola will be shifted up 2 units from its original position. This is the original position. Same parabola shifted up 2 units from its original position. Same parabola shifted up 2 units. So this is y minus 2 whole square equal to x minus 1. This is y minus 2 whole square equal to x minus 1. So first of all, let me draw a tangent. Before this, first of all, what is the given parabola? Given parabola is y minus 2 whole square equal to x minus 1. First of all, you should know equation of the tangent. So to get equation of the tangent, first you have to find the slope. To get slope, differentiate both sides of this equation with respect to x. Y minus 2 whole square derivative 2 into y minus 2, and again y derivative with respect to x is dy by dx equal to x derivative with respect to x is 1. So this is, from this dy by dx is, from this dy by dx equal to 1 by 2 into y minus 2, because you have to draw a tangent to the parabola at the point 2 comma 3. Therefore you need slope of the tangent. We require slope of the tangent at the point 2 comma 3. So slope of the tangent denoted by m, also denoted by dy by dx. So slope of the tangent required at the point 2 comma 3. So substitute x equal to 2, y equal to 3 there. Then it becomes 1 by 2 into y value 3, 3 minus 2, 1. So slope of the tangent is 1 by 2. What is the equation of the tangent? Because you have to draw the tangent to the parabola at the point 2 comma 3. Rough diagram I am saying, rough diagram, you want equation of the tangent to the parabola at the point 2 comma 3. At the point 2 comma 3. So equation of this tangent we have to find. This tangent is drawn to the parabola at the point 2 comma 3. So therefore equation of the tangent formula, y minus, here y coordinate, this is x1, this is y1, y minus y1, y1 value 3, y minus y1 equal to m, m means slope, that is 1 by 2 into x minus x1, x coordinate is 2, x coordinate is 2. So from this find x value or y value, so multiply both sides by 2, then it becomes 2y minus 6 equal to x minus 2. So from this find x value. So from this minus 2 will go this side. So x equal to 2y minus 6 plus 2. Minus 6 plus 2, that is minus 4. This is equation of the tangent to the parabola. So first of all, now we have to draw the diagram. Rough diagram only. And draw a tangent to the parabola. Draw a tangent to the parabola at the point 2 comma 3. Tangent has been drawn to the parabola at the point 2 comma 3. To know this parabola where it touches x-axis, to know this tangent, this is equation of the tangent. To know where it touches x-axis, substitute y equal to 0. If I take y equal to 0, x value minus 4. So that means x value minus 4 on x-axis, y coordinate 0. I mean this parabola touches x-axis at minus 4, this tangent touches x-axis at minus 4 comma 0, that's fine. And to know this is the parabola, to know this parabola where it touches x-axis, to know your parabola where it touches x-axis, substitute y equal to 0. If you take y equal to 0, then 0 minus 2 whole square, 4 equal to x minus 1. So from that x equal to 5. So this parabola touches x-axis at 5. Now sketch the area occupying by x-axis, tangent and parabola. This is the area occupying by x-axis and everything. This. Now what is the area formula? What is this parabola equation? Parabola equation, y minus 2 whole square equal to x minus 1. So from this, what is x value? Y minus 2 whole square plus 1. So that is x value. So what is the area formula? Now let us write. Area equal to integral a to b x dy. That is integral upper curve x value minus, right curve x value minus left curve x value. What is right side curve? Total shaded region, this is right side curve. Right side curve x value, y minus 2 whole square plus 1. Right side curve x value, y minus 2 whole square plus 1 minus left side curve x value. Left side curve means this is left side curve. What is this left side curve? Straight line. Tangent. Tangent is x equal to 2y minus 4. Area formula, right side curve x value, total shaded region right curve x value minus left curve x value. Minus of left curve x value, that is 2y minus 4 into dy. So we are integrating with respect to y, so we just need y limits. So here starting point y limit 0, ending point y limit 3. So y limits 0 to 3. So then we have to simplify this. Then you will get answer 3, 0 to 3, y minus 2 whole square, that is y square minus 4y plus 2 square, 4 plus 1, 5, minus into 2y minus into minus 4 plus 4 into dy. So from this integral 0 to 3, this is y square minus 4y minus 2y minus 6y plus y plus 5 plus 4, 9 into dy. This is equal to integral 0 to 3 y minus 3 whole square. Y minus 3 whole square. Dy I can write dy minus 3. Dy I can write dy minus 3 because d of 3, differential of 3 0. Differential of 3 0. Dy equal to dy minus k because differential of k 0. D into y dy, okay, derivative or differential of 3 will be 0. So I can write like this. This is y minus 3 whole square. So therefore treat it as t, integral t square dt, integral t square dt, that is t cube by 3. T cube by 3, that is y minus 3 whole cube divided by 3 between the limits 0 to 3. So replace, otherwise we can do like this. Otherwise we can simplify like this also. Instead of doing, then we can directly simplify. So integral y square dy, that is y cube by 3 minus 6y square by 2. 6y square by 2, that is 3y square plus 9y between the limits 0 to 3. So replace y by upper limit 3 cube, 27 by 3, 9 minus 3 into 3 square, 27 plus 9 into 3, 27. So minus 27 plus 27 cancel, answer 9. Directly we can write. What is the purpose of directly writing y minus 3 whole square? We can directly getting the answer. It is 9. Now you observe which of the following statements it is MSQ, which of the following statement is true, or which of the following statements are true. It's a property you should remember properties of rank of a matrix. As we all know, rank of A plus B less than or equal to rank A plus rank B, rank of A minus B greater than or equal to rank A minus rank B. So accordingly, options B and D are true. Next, you observe this question carefully. Two boxes contains 10 chips each. So first box has 10 chips numbered from 1 to 10. Second box will also have 10 chips numbered from 1 to 10. And one chip is drawn at random from each box. The probability that sum of the numbers drawn on the chips is greater than 4. So instead of doing sum of the numbers drawn on the chips is greater than 4, it is easy to calculate sum of the numbers on the chips drawn should be less than or equal to 4. So that's why let us assume A equal to sum is less than or equal to 4, because sum of the numbers on the drawn chips should be less than or equal to 4, I assume. So A complement means exact opposite meaning of less than 4. Exact opposite meaning of less than 4 is sum greater than 4. We were asked to find sum of the numbers on the drawn chips is greater than 4. Sum greater than 4. Probability of sum greater than 4 means we have to find P of A complement. P of A complement value 1 minus P of A. So before that, first look favor. So first you observe favorable cases or total cases. Total cases how many? Two boxes contains 10 chips each. So first box has, from the first box one chip is drawn. So 10C1, from the second box one chip is drawn, 10C1, 10C1 into 10C1, that is 10 into 10, 100. So favorable cases for A. Favorable cases for A, 6 cases, as you can see now. So favorable cases for A means favorable cases for sum of the dots on sum of the numbers on two chips is less than or equal to 4. So these are 1, 1, 1, 2, 1, 3. First chip, first box 1, second box chip 1. So sum is less than or equal to 4. Sum is less than or equal to 4. Next, 2, 1, 2, 2, 3, 1. These are the cases where sum is less than or equal to 4. Total how many cases? 6 cases. So probability of A equal to favorable cases 6, total cases 100. This is probability of A. Then actually we have to find P of A complement, no? So that is 1 minus P of A, that is 1 minus 6 by 100, that is 94 by 100, that is 0.94. That is 0.94, right? So it is a fill in the blank question. So answer 0.94. Next, you observe this. Consider the following system of linear equations. Consider the following system of linear equations. If the system has at least one solution, then what is the value of lambda? Do you know if the system of equations are consistent? Consistent means at least one solution. At least one solution meant for consistent. So for what value of lambda system of equations is consistent? Means for what value of lambda rank of AB equal to rank of A. That is to be shown. That is to be proved. So for that directly let us write augmented matrix. Augmented matrix AB equal to first equation XYZ coefficients first row 3 minus 1 4, 3 minus 1 4, second equation XYZ coefficient second row 1 2 minus 3, third equation XYZ coefficients third row 6 5 lambda, First equation right side 3, second equation right side minus 2, third equation right side minus 3. 3 minus 2 minus 3. Minus 2 minus 3, reduce this augmented matrix AB to echelon form. So for that, we have to select the first row, first element. Using the selected element, all elements below it must be made zeros with the help of row operations. Make these two numbers zeros using this number. That I can write 3R2 minus R1 and R3 minus 2R1. R3 minus 2R1. So the augmented matrix AB equal to, first row no change, 3 minus 1 4 3, 3 times of second row minus first row, 3 into 1 3, 3 minus 3 0, 3 into 2 6, 6 plus 1 7, 3 into minus 3 minus 9, minus 4 minus 13, next minus 6, minus 3 minus 9, third row minus 2 times of first row, that is 6 minus 6 is 0, 5 minus 5 plus 2 7, lambda minus 8, lambda minus 8 minus 3 minus 6 minus 9. So once we make all elements below the first row, first element as zeros, then go to the second row, second element and select the second row, second element if it is some non-zero number. Once it is selected, using the selected number only, below elements are to be made zeros. Means make this number 0 using this number with the help of row operations. That is third row minus second row. Your row operation would be third row minus second row. So rewrite the augmented matrix AB now. So AB equal to 3 minus 1 4 3. 0 7 minus 13, 0 7 minus 13, I think minus 9. Yeah, fine. So third row minus second row, 0 minus 0, 7 minus 7, 0 0, lambda minus 8 minus of minus 13, lambda minus 8 plus 13, 13 minus plus 13 minus 8, 5. So lambda plus 5, 13 minus 8, next minus 9 minus 9, minus 9 minus of minus 9 plus 9 0. So this is the augmented matrix AB and it was reduced to echelon form. As you all know, from here to here matrix A, from here to here matrix B. This is matrix B. So for what values of lambda, rank of A equal to rank of AB such that the system of equations to be consistent. If I take lambda equal to minus 5 here, minus 5 plus 5, 0. So then this row will become 0 0 0. Then matrix A will contain only two non-zero rows. So rank of A 2. If I take lambda equal to minus 5 here, it is 0. Then matrix AB also contains two non-zero rows. So matrix A rank 2 and matrix AB rank 2 for lambda equal to minus 5. So rank of A equal to rank of AB for lambda equal to minus 5. For lambda equal to minus 5, rank is denoted by this symbol which we read it as rho. Rho of A means rank of A. Rank of A equal to rank of AB. Therefore, system consistent. System consistent means system will have at least one solution. System has at least one solution for lambda equal to minus 5. Next, observe this. You are asked to find, look at this question. We were asked to find sum of the residues of the function f of z equal to z cube by z minus 2 into z minus 3. So first denominator is to be equated to 0. Let me write the given function first. Given f of z equal to z square by z minus 2 into z minus 3. Denominator is equated to 0, whatever the z values we get, which are called singular points. If I take z equal to 2 in the numerator, 2 square, so 2 cube. If I take z in the numerator, sorry, that's fine. And observe, first of all, write the given function f of z equal to z cube by z minus 2 into z minus 3. Denominator is equated to 0, whatever the z values we get, which are called singular points. If I take z equal to 2 in the numerator, numerator becomes 2 cube, 8. That means a numerator not equal to 0 at z equal to 2. Therefore, z equal to 2 is a simple pole. In the similar manner, z equal to 3 is also a simple pole. So, these are the simple poles. Simple poles means pole of order 1. So, calculate the residue at each simple pole. So, I am calculating residue of f of z. I am calculating residue of f of z at the simple pole z equal to 2. Z equal to 2, this is equal to z equal to 2 simple pole obtained from this part of the function. Therefore, to get the residue at the simple pole z equal to 2, simply delete this part and put z equal to 2 in the remaining part. Whatever you get, that would be the residue at that simple pole. So, delete this part and substitute z equal to 2 in the remaining part. Then it becomes 2 cube by 2 minus 3, 2 cube 8, 8 by minus 1, that is minus 8. Similarly, let me calculate residue of f of z at the pole z equal to 3. To get the residue at the simple pole z equal to 3, z equal to 3 simple pole is obtained from this part of the function. So, to get residue at the simple pole, simply delete this part and put z equal to 3 in the remaining part. Whatever you get, that would be the residue at z equal to 3. Simply substitute z equal to 3 in the remaining part, then it becomes 3 by 3 minus 2. So, that is 27. So, we were asked to find sum of the residues. Sum of the residues is minus 8 plus 27, that would be 19. 19. Sum of the residues is 19. It's a fill in the blank question. It's not fill in the blank question. MCQ option A, 19 is correct. Next, you observe this. Read out the question carefully. 3 persons ABC in order roll a fair die. The first one to roll an even number wins the game and the game is terminated after that. Assume that person A rolls the die first, the probability of A winning the game is. So, the question, it is a standard question. This model was given several times in the GATE exam. 3 people ABC are throwing a die in the order ABC. First A will throw, next B will throw, next C will throw. Again A will throw, B will throw, C will throw. ABC, ABC, ABC. So, 3 people ABC are throwing a die in the sequential order A first, B next, C next. I mean ABC, 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 so on, until one of them gets an even number on the die first. Whoever first gets even number on the die first, that fellow can win the game. Assume that player A starts the game. Probability of player A winning the game is. It's a standard question, everyone should remember, and we have a derivation. It's probability of A winning the game. It is a standard question and answer is also standard. So, that is P of A by 1 minus P of A complement whole cube. So, 3 people know, that's why it is whole cube. Suppose 2 people, it is whole square. 4 people, it is whole power 4. Now, first let me write probability of A winning the game, probability of A winning the game, probability of B winning the game, probability of C winning the game, same. Because whoever gets even number on the die first, that fellow can win the game. Probability of A winning the game means probability of A getting number 6 on the die. Probability of A getting number 6 on the die is 3 by 6, that is 1 by 2. Similarly, probability of B winning the game is probability of B getting even number on the die, that is 3 by 6, 1 by 2. So similarly, P of A complement, P of B complement, P of C complement, this is also 1 minus 1 by 2. Now put this data there, probability of A wins the game equal to, what is the formula? P of A, numerator. So P of A means 1 by 2 by 1 minus denominator P of A cube. P of A cube 1 minus A cube means 1 by 2, 1 by 2 whole cube, that is 1 by 8. So this is equal to 1 by 2, 1 minus 1 by 8, that is 7 by 8. So that is equal to 1 by 2 into 8 by 7, that is 4 by 7. So probability of A winning the game is 4 by 7. So probability of A winning the game is 4 by 7. Therefore option D is the right answer, 4 by 7. Now you look at the differential equation. If the differential equation, so you are asked to find complementary function and particular integral. So first of all, as you all people know, this is Cauchy-Euler. Cauchy-Euler is x square into d square y by dx square is replaced by d into d minus 1 into y, or theta into theta minus 1 into y, minus plus into minus minus x into dy by dx is capital D into y. X into dy by dx is capital D into y plus 5y equal to right side x. Right side x, as you all know, in this model assumptions would be log x equal to t, so that x equal to e to the power of t. That is the assumption, as we all know. So therefore right side x is there, so x means e to the power of t. So y common factor d into d, d into d, d square, d into minus 1 minus d into y minus dy, minus 3 dy, minus 4 dy, y common, plus 5y, y common. So this equal to e to the power of t. So write the auxiliary equation in order to find the complementary function. Auxiliary equation d square minus 4d plus 5 equal to 0. Find the roots. This is a d equal to 4 plus minus square root of b square minus 4 whole square 16 minus 4 ac 20 divided by 2. So that is root minus 4. Root minus 4, I can write it as 4 plus or minus root minus 4 by 2. D equal to root minus 4 can be written as square root of 4i square. I square or j square? By 2. I square value minus 1 into 4 minus 4. So this is equal to 4 plus minus 2i divided by 2. Next to 4 by 2, that is 2. Plus minus 2i by 2, that is I. 2 plus or minus I. Roots are conjugate, complex conjugate, a plus or minus ib. A plus minus ib, then what would be the complementary function? Complementary function would be e power ax, a plus minus ib, e power ax 2x, c1 cos b, e power ax, at, because capital D means d by dt in this model. c1 cos bx, b value 1, plus c2 sin bx, b value 1, x means t, because capital D is d by dt. So complementary function, this is x square, x equal to e power t, so that x square equal to e power t whole square, that is e power t into e power t, e power t into e power t, that is e power 2t. c1 cos, our assumption for t would be log x, plus c2 sin t means log x. Complementary function completed, x square into c1 cos log x plus c2 sin log x. Option A correct. The complementary function is x square into c1 cos log x plus c2 sin log x. So option A, as of now, option A correct. Now let us calculate particular integral as well. So pi equal to 1 by dependent variable y coefficient, that is d square minus 4d plus 5. D square minus 4d plus 5 into right side of the given differential equation t. So to solve type 1 particular integral, d should be replaced by 1 e power ax, a value 1, x means t. Replace d by 1, then it becomes 1 by 1 square minus 4 into 1 plus 5 into e power t. 1 plus 5 6, 6 minus 4 2, so 1 by 2 into e to the power of t. But what is our assumption for e power t? E power t is x by 2. So particular integral x by 2. So option B also correct. The particular integral is x by 2. So option B also correct. Option C wrong. The particular integral is 2x wrong. And option D is correct. The general solution is x square into c1 cos log x plus c2 sin log x, that is CF part, I mean complementary function part, and particular integral is x by 2. That's it. Therefore option D is also the right answer then. Next question and the last question then. So don't get confused, it's a printing mistake. X limits 0 to 1, not x, see here, not x limits 0 to 12. So little bit gap should be there. So x limits 0 to 1, y limits x squared to 2 minus x, xy dy dx. Now let us solve this. The given question, let it be I. For my convenience, I would like to assume it as capital I means integral, where x limits 0 to 1, y limits x squared to 2 minus x, xy dy dx. Order of integration first y and then x. So when you are integrating with respect to y, at that time y is only the variable, other variable x is kept constant. So x a constant, integral y dy, that is y square by 2 between the limits x squared to 2 minus x into dx. This two I will write it out. Therefore it is equal to integral 0 to 1 x by 2 into, replace y by upper limit 2 minus x whole square minus replace y by lower limit x square whole square. Now into dx is there. So I equal to 1 by 2 into integral 0 to 1, take this x first of all, x into, what is this bracket, 2 minus x whole square. 2 minus x whole square is 4 plus x square minus 2x, sorry, 4 plus x square minus 4x, 4 plus x square minus 4x minus x power 4 into dx. So 1 by 2 into integral 0 to 1 x into, so take this x inside, then it is a 4x plus x cube minus 4x square minus x into x power 4 x power 5 dx. So this is equal to 1 by 2 into integral 4x dx, 4x square by 2, that is 2x square, x cube integration x power 4 by 4 minus 4 x square integration x cube by 3 minus x power 5 integration x power 6 by 6 between the limits 0 to 1. So replace x by upper limit 1, 2 into 1, 2 plus 1 by 4 minus 4 by 3 minus 1 by 6. So simplify that. This is equal to 2 into 1 by 2, that is 1, plus 1 by 2 into 1 by 4, 1 by 8 minus 2 by 3 minus 1 by 12. This is the integral value. And observe, this is equal to 1 minus 2 by 3, that is 1 by 3, plus LCM of 8 and 12, that is 24, 8 3s, 12 2s. So this is equal to 1 by 3 plus 1 by 24, and LCM of 3 and 24, 1 by 3 can be written as 8 by 24 plus 1 by 24. I just wrote 1 by 3 as multiply and divide by 8, 8 1s 8 3s, 8 by 24 plus 1 by 24, that is 9 by 24, that is 3 3s, 3 8s, 3 by 8, I think 0.375. 3 by 8 answer, I think 0.375. That's it. That is the answer.
Hello friends, let's have a look at the solutions of general aptitude. I'm dealing with numerical ability and logical reasoning part. In that one, first one that is given is find the remainder when 2 power 101 is divided by 5. There are different methods of attacking this problem. I'll deal with one simple technique here, that is concept of negative remainder. Or you try to adjust the power of 2 in such a way that when you are dividing that with 5, you are going to get a remainder of either plus 1 or minus 1. You try to adjust in that manner. Like if you check it that way, so this can be written as 2 to the power of, when you know, like 2 when divided by 5, remainder will be 2. 2 square when divided by 5, remainder will be 4. Or I can also call it as minus 1. Because when you divide 4 with 5, remainder can be either 4 or minus 1. Keep that in mind. Now if you can understand this one, so solving this problem becomes very easy. Now going ahead with this 2 power 101 divided by 5 is what we are looking for. So you simply write it as remainder of 2 power 101 can be written as 2 square whole to the power of 50, that is 2 power 100 into 2 power 1. This is what I can say. So remainder of when you are dividing that with 5. So it is as simple as when you are dividing this 2 square with 5, remainder is nothing but minus 1, you know. When you divide this 2 square with 5, remainder will be minus 1. When you are dividing the number which is to the power of 50 for that, the remainder will be minus 1 to the power of 50. Into, when you divide 2 power 1 with 5, remainder will be 2. So effectively remainder will be minus 1 to the power of 50 will give you 1 into 2. So that will give you a remainder of how much? 2. I repeat, whenever you are dividing a particular number, you try to adjust the number in such a way that it is either 1 more or 1 less than power of 5 or multiple of 5, I can say. So I am just writing this 2 power 1 as 2 power 101 as 2 power 1 is 2, remainder will be 2 when I am dividing it with 5. 2 square when divided by 5, remainder will be either plus 4 or minus 1. This is called as concept of negative remainder. Now you try to write it in such a way that this is to the power of 2 square only, such that the remainder will give you minus 1. When you divide this 2 square with 5, remainder will be minus 1. Minus 1 to the power of 50 will give you 1 only into 2. So 1 into 2 will give you 2. Say suppose you are having an odd power over here, you will get minus 1 here. If your answer you are getting here is negative, you add it to the divisor. So that is 5. If you are getting minus 2 here, you add minus 2 with 5, that will give you 3 as the remainder. If you are getting a positive remainder, so that will be your answer. So hence your answer has to be what? 2 here. It can also be done by a method called as concept of cyclicity also. By cyclicity method also this can be done, right? So coming to that method of cyclicity over here, So what is that method of cyclicity? Let's understand that also. So coming to second method. When you are dividing 2 power 1 with 5, remainder will be 2. 2 square when divided by 5, remainder will be 4. 2 cube when you divide it with 5, remainder will be 3. 2 power 4, 16 when divided by 5, remainder will be 1. So 2 power 5, 32 when divided by 5, remainder will be 2. That means this remainder is repeating after 4 powers. That means whenever you are having a particular power for 2, after every 4 powers, this remainder of 2 will keep on repeating. That means if you go ahead with this 2 power 101 can be written as, you just simply check this one. 2 power 101 is equal to what? So remainder of 2 power 101 will be equal to, so you are getting a cyclicity of 4 now. You are getting a cyclicity of 4 means after 4 cycles the remainder is getting repeated.
You simply do one thing. Divide this 101 with the cyclicity. Divide this 101 with the cyclicity. Cyclicity means after how many powers it is repeating. Take the remainder here. 101 by 4 is equal to what? Remainder you take. 425 is 100. Remainder will be 1. It is as good as 2 power 1 remainder. 2 power 101 remainder will be same as 2 power 1 remainder. What is the remainder when you are dividing 2 power 1 with 5? That is 2. Hence I can say that the remainder will be how much? 2 simply. So I repeat, remainder of 2 power 101 will be equal to remainder of 2 power 1 when divided by 5. Hence it has to be what? 2. As simple as that. Coming to the next one. This is a problem related to number series. Right? Going ahead with 10, 30, 68, 130, 222. The next term in the given series is what? So 10 can be written as, if you are having an idea about, as I said in the classes, as we generally suggest when discussing number series, try to know the squares and cubes of the numbers up to 25. That will help you a lot in cracking the problems related to number series. So here 10 is nothing but, I can simply write it as 2 cube plus 2 is 10, 3 cube plus 3 is 30, 4 cube plus 4 is 68, 5 cube plus 5 is 130, 6 cube plus 6 is 222. Hence it has to be, next one is what? 7 cube plus 7. We know that 7 cube is 343, 343 plus 7, 343 plus 7 should give you how much? 350. Hence it has to be option D here, right? As simple as that. So please be aware of that squares, cubes. So if you are aware of that squares and cubes, it is easy for you to identify that is related to which particular number. If you are not learning that squares and cubes, you will always have a doubt. See, the fundamental mistake that many people do here is, they will try to look at the difference or multiplication always. And so not always the series may be having difference or multiplication property, right? Keep that in mind. Let's go ahead with the next one. These two are for given for 1 mark each. Next one. There is a window which is in the shape of a semicircle fixed on a square. There is a semicircle which is fixed on a particular square. The side of the square shape is 14 meters. So the side of the square shape is given as 14 meters. Then find the area of the window. So area of the window is nothing but area of the square plus area of the semicircle is what I can say, right? So if you observe this entire thing for the circle will become the diameter of the circle. If the diameter of the circle is 14, radius will be 7. So radius of that circle will be 7. So area of the window is nothing but area of the semicircle plus area of the square is what I can say. Area of the semicircle plus area of the square. Now going ahead with area of a semicircle is nothing but half of pi r square. Half of pi r square is the formula for the area of a semicircle, plus area of the square is nothing but side square. So half of pi r square. Now going ahead with half into pi is nothing but 22 by 7 into r square is nothing but, don't take 7 square 49, you write it as 7 into 7 plus side is 14 square. That is this is the area of the square. Now going ahead with now. So here 7 gets cancelled. Here 2 11 times. 11 7s are 77 plus 14 square is 196. 196 plus 77 adds up to 273. Hence it has to be option A. So here the area is a combination of the area of the square plus area of the semicircle. That's the only point that you have to be aware of, right? Let's have a look at the next one. This is a problem related to data interpretation part over here, which is a combination of one pie chart, the other one table. So it's a combination of pie chart and table put together. Now going ahead with, the following pie chart shows the number of employees falling under different categories based on their work, and a table shows ratio of male to female in particular category. So pie chart is given. So they are talking about different types of people who are lazy, hardworking, skilled and efficient, and in every category the ratio of the male and female is also mentioned over here. Now, number of employees in the company is given as 22,500. This entire number of employees is corresponding to 22,500, which is nothing but 100% is 22,500. Now, going ahead with, then the number of skilled male employees exceeds the number of lazy male employees by how much? Number of skilled male employees. So, skilled male employees, first of all, how many people are there in skilled? 20% are there in skilled. Out of the 20% of the total, male and female are in the ratio 2:3. Hence, I can say that number of male employees who are skilled is nothing but 2 parts out of 5 parts. So, this total is adding up to 5 parts. So, divide that into 5 parts. So, 2 out of 5 I can say 2 out of 5 of 20% of 22,500. 22,500. That represents the number of skilled male employees. Number of skilled male employees is corresponding to this much. So, 20% of this is nothing but 10% is 2,250, 20% is 4,500. That is as simple as 2/5 of 4,500, which is nothing but 1,800. That is the number of skilled male employees. Number of skilled male employees. Coming to the number of lazy male employees. Total lazy employees are how much? 30% of the total. 30% of the total are lazy. Out of that lazy people, how many are male? So, ratio of male and female is 1:4. That means divide this into 5 parts. Out of that, 1 part is male. Hence, I can say that 1 out of 5 out of 30% of 22,500. 30% of 22,500. Right? Now, going ahead with. So, here if you go ahead with 10% of this is nothing but 2,250. 30% is nothing but 3 times of that, which is 6,750. So, 1/5 of 6,750. So, if you go ahead by cancelling this one, this will give you how much dear? If you cancel it with this one, that will give you 1,350. So, this is 1,350, this is 1,800. The question is, what is the difference between those two values? What is the difference over here? 1,800 here, 1,350 here. The difference is coming out to be 450. Hence, it has to be option A. Right? Next. This is a problem based on spatial aptitude, where they are talking about the mirror image. Right. Going ahead with. Which of the following option is right image of prayer with respect to y-axis? With respect to y-axis means here is the mirror. Mirror is located over here. Just remember one thing, whenever you are looking at the mirror, left will become right, right will become left, left will become right, right will become left. Whenever you are looking into the water, top will become bottom, bottom will become top. The difference, if you can understand handling, this is very simple. Now, if this is prayer, if this is looking at the mirror over here, left will become right, right will become left. So, you can say that P is here, so that P looks like this in the mirror, P looks like that in the mirror. So, if you observe the options over there, so it starts like this, P, so ending one will be P. So, after that R will come, so R will look like this. So, look at the option which is having that way. There is only one option which is satisfying that. Hence, it has to be PR. So, whenever you are solving, don't try to solve the entire problem. Look at the options. So, if you look at the options over here, this is very simple. After P, after P itself, you can decide. So, last letter should be P, and that should be left should be becoming right, and right should be becoming left. Right. Next, this is related to verbal reasoning. This is also related to verbal reasoning. Right. All these are verbal. So, those are the questions that are given from reasoning and aptitude part. Thank you and wish you all the best.
Hi guys, let's look at the solutions. Read this. It will take time for the higher rates to feed dash to investors. It's a phrasal verb. He has given a verb asking you to supply the tail, particle we called. Now look at the meanings. If I say feed through, convince, feed up, giving large amount of food, feed off. Feed off is like drawing inspiration or drawing strength from or drawing energy from other source. And feed on, like consume, eat for survival, living. Now with this, I think you can make out, it will take time for the higher rates to feed through. That's the right word there. Choose the option to fill in the blank. Grammatical problem. Teacher asked two students the answer of a question, okay? But, look at the clue here, but dash of them no, dash of them no. So I am looking for the negativity here. None, either, both. Straight away I eliminated these two because if I put this, it gives the a positive meaning. I am looking for the negative. So none is a short form of no one. No one, none. Neither, not either. So when I am talking about two, the obvious choice is this, not this. If it is more than two, I would go for it. So answer is D. Which one of the following is correct with respect to grammar and usage? Obviously, look at this, guys. Ladakh is more colder than Kashmir, and you have a clue here. Than, obviously, we need a comparative form, and you have comparative form, but look at this one. This is called double comparative, which is obviously wrong. Okay, colder is enough. I don't need more here. That's the reason, gone. Kashmir is not so cold as Ladakh. Okay, we call it as equality, inequality. Yes. Kashmir is less colder. Again, double comparative. Ladakh is cold compared to Kashmir, and the wrong degree of comparison. Colder should be there. So, Kashmir is not so cold as Ladakh. Generally, guys, you might have observed as positive degree as. Suppose if I want to say in another way, Kashmir is as cold as Ladakh. If you want to say equality, here only focus on the grammatical part. If it is inequality, yes, you say so positive degree as not. This structure is accepted. If it is equality, you say as positive degree as. If it is inequality like this, not so positive degree as. That's the right construction, it's right. Fine. Which of the following pairs that best expresses relationship similar to that expressed in the main pair? Analogy. Okay. So correct is to error, whereas you need to find out. Analogy is about finding out the relationship between this word and this word. Now if you observe, now my technique is, guys, you try and put a verb here or make a kind of statement. Errors can be corrected or error is corrected. That's a sentence I frame, and I see that kind of relationship, correction or this. Now assistance is lobbied. Lobbying is a kind of influencing someone unofficially to get the things done, and assistance is lobbying, kind of, going with that. Now here error can be corrected. Little bit of opposite idea is there. Appearances are decorated. Okay, fine. Appearances are decorated is again a positive effect. We don't find this kind of relation. Errors can be corrected so that it gets better. Appearances are decorated. Oh, it's maybe better. We'll see. Conviction is affirmed as a belief, and it is affirmed. And sin is expiated. Expiate means we call it as atonement, kind of what you say, prayashchit. Okay, so kind of mistake and correction, right? Whereas here appearance decorated, it is like enhancing that. Whereas here errors are corrected. Like that, sin is expiated. As I said, prayashchit. So this is the right one. Fine. Look at this one, jumbled sentences. In the following item, the passage consists of 6 sentences, okay? The first sentence S1 and the sixth sentence S6 are given in the beginning. The middle 4 sentences have been removed and jumbled up. These are labeled P, Q, R and S. You are required to find out the correct sequence of the 4 sentences and mark accordingly. Agreed. First read the S1. Today, the Earth has many satellites besides the moon. Okay. Once again, today the Earth has many satellites besides the moon. That is the beginning of the sentence. Now go through the options, I mean P, Q, R. But the pull of the Earth keeps them from doing so. Whenever I go for the other idea, I always see the link. It can be the extension of that, it can be opposite of that, or it can be explanation of that. Some kind of link should be there between these 2 sentences. So here I don't really see any idea linked here, isn't it? But the pull of the Earth keeps them from doing so. Fine. Next, the artificial satellites do not fall because they are going too fast to do so. He just mentioned satellites, but no mention of artificial satellites anywhere here in the first one. So I go ahead. They are artificial satellites made by man and very much smaller than the man. Next, as they speed along, they tend to go straight off into space. Okay, now I think you got it. Today the Earth has many satellites besides the moon. So he's talking about satellites, many satellites. Then they are artificial satellites made by man and very much smaller than the man. Immediately he is talking about they. They refers to, many satellites besides the moon. So immediately we know R. So here this is examination point of view. You don't have to really go through all the sentences first. Find out the options where I have R in the beginning. P, Q, R, S. I think work is done. You don't have to really, rack your brain. This one. I don't have any other option where it is competing with this. R, Q, S, P. They are artificial satellites made by man and very much smaller than the man. Q. Where's Q? The artificial satellites do not fall because they are going too fast to do so. There's a link still talking about, then that's an extension of that. And S. Where's S? P, Q, or S. As they speed along, they tend to go straight off into the space. Yes, there is a link between the not falling and the speed. And P. But the pull of the Earth keeps them from doing so. I think it is pretty straight, easier one. So, answer is C. Thank you.